Okay, good morning again, ladies and gentlemen. Welcome to talk concert today. Let me briefly introduce myself. I'm Sung-Hoon Hwang, a professor at Gachon University. Let me briefly introduce today's talk concert. This talk concert will be held as a side event of the BrainLink X Days. As you saw previously, it was held from July 8th to 10th with the theme of security, privacy, and trust in AI at the Sheraton Grand Hotel in Incheon, with the full support of Korea Federation of Science and Technology Societies. To hold the event, we invited 10 distinguished overseas scientists and 35 domestic researchers in this area. Throughout this event, we successfully exchanged the state-of-the-art technologies in AI and cybersecurity and discussed the formation of a sustainable exchange network that can conduct global joint research in the future. Today, those 10 overseas scientists are invited here again to share their personal experience with the theme of how to conduct research and how to manage career. I am sure that you are very interested in this topic as a student or as a researcher. I'm also wondering, for example, what is the secret to their success? What challenges did they face and how did they overcome them? Am I doing right? Okay. All those questions, I hope you get some answers or insight to those questions. Let me speak in Korean, surely. 그래서 여러분들은 지금 브레인링크 행사장에 왔습니다. 이게 뭐지 할 수가 있는데요. 브레인링크는 전 세계적으로 아주 유명한 석학들을 모시고 기술 교류도 하고 또 더 나아가서 네트워킹을 통해서 앞으로 협력 연구를 할 수 있는 그런 발판을 마련하기 위한 국제 행사입니다. 이 행사는 한국과학기술총연합회라는 단체에서 후원하에 열리게 됩니다. 그래서 이 행사를 개최하기 위해서 저희가 가천대와 또 호주에 있는 사이로라는 연구기관이 협력을 하여서 해외 과학자 10분, 그 다음에 국내 과학자 35분, 그래서 총 45분을 모시고 이번 주 월요일부터 수요일까지 2박 3일에 걸쳐서 인천에 있는 셰라톤 그랜드 호텔에서 행사를 가졌습니다. 행사를 가졌고요. 아주 성황리에 끝냈습니다. 그래서 오늘은 그 행사의 부대 행사입니다. 부대 행사로 일반 대중한테 저희의 이 어떤 행사를 알리고 또 더 나아가서 또 일반 대중들이 관심 있는 그런 사항들에 대해서 특히 어떻게 연구할 것인가, 또 어떻게 경영을 관리할 것인가 이런 주제를 중심으로 해서 오늘 토크 콘서트를 진행하도록 하겠습니다. Okay, let me introduce another moderator, Dr. Jason Zhu. He is a scientist at CSIRO in Australia. CSIRO is a representative science agency in Australia. He is an overseas organizer. He will help run this program. Please.
So thank you very much, everyone, for coming here today. And firstly, as a senior research scientist at Commonwealth Science and Industrial Research Organization in Australia. And on behalf of all the international scholars here, I would like to express my huge thanks for COFST, Korean Federation of Science and Technology Societies, and also Professor Huang for hosting us, not only in Incheon, but also in Seoul, Gachon University. And it's a fantastic event, and we would like to appreciate very much for all the things you've done for us. Thank you very much. So now I would like to start our stand-up show for our international speakers today. And the first speaker, I think, is Jeppen, who is associate professor from Radboud University, the Netherlands. And he will talk about his own research and show how he can manage between the AI and hardware and software. So Jeppen, the stage is yours.
I think it's fine, thank you. So, welcome everyone. Today I will talk very briefly about AI and cybersecurity with a bit more emphasis towards hardware security and, let's say, even cryptography. So, just shortly about me, I'm associate professor in the digital security group in Radboud University in Netherlands. Before that, I was also in Netherlands at Delft University of Technology, and before I worked at MIT and KU Leuven as postdoctoral researcher. My main research interest is intersection of AI and cybersecurity. So if it has security flavor and AI flavor, most likely I'm interested in it. But of course, there are some aspects that I know better. So first question is, why artificial intelligence? Recent saying is AI is the new electricity. And AI is today really used everywhere for many, many things. So for computer vision, healthcare, natural language processing, robotics. So we accept today that AI is a natural part of that. But actually, today, AI is also a natural part of cybersecurity. What does it mean? It means there are so many different applications where we can use AI to make the systems more secure, as such better, but it's also to assess how secure AI systems are on their own. So here I list a number of applications that are more connected, let's say, with hardware aspects, but not exclusively, where AI found its place. So in the design of random number generators, evaluation of random number generators, in various kinds of implementation attacks, being passive side channel or active fault injection attacks, in the design and attacks on hardware trojans, attacks on physically unclonable functions, then design of cryptographic primitives. So when you want to design a cipher, some element of a cipher, you can use AI to design it in an automated way. In cryptanalysis today, we also use AI a lot. And then for some more general applications of AI in cybersecurity, intrusion detection, malware, spam identification detection, those are all topics where AI is used today a lot, and we all use it every day, even if we don't realize. Whenever we open mail client or something and we see some mails in spam, actually those mails are in spam because there was some kind of AI deciding it should be spam. And then, of course, huge topic on its own, security of machine learning, where we ask the question, okay, we use machine learning all the time, but how secure are systems like that against various kinds of attacks? Security fuzzing, again, a topic where today we would be nowhere without AI, privacy preserving machine learning, and so on. Okay, so what are my research goals? What do I aim to do most of the time? So I like to evaluate the security of software and hardware, mostly from the perspective of the attacker. So we do attacks, but the attacks are done such that we can assess how secure a system is. And once we know how secure a system is, then we improve security by developing novel defenses, countermeasures, and the whole designs. Here you can see some very nice figures designed by Hammond in a way, but really by ChatGPT. So these are examples of what can be done with AI in also nicer way, simpler way. And these, here you can see a couple of results of my research. So for instance, here you can see our usual setup when we are doing side channel attacks. You can see a target here, a microcontroller, and here is a probe, and then oscilloscope measuring electromagnetic radiation. From that radiation, getting secret information. Here you can see a laser. With laser we inject faults. By injecting faults, we make the devices work in a different, wrong kind of way. From there we can again get the secret information. Here you can see a side channel attack where we attacked 8 ATM machines, and more precisely when you type something, your PIN, and then still, even when you hide your hand by movements of the muscles, deep learning can tell us what your PIN is. And then here you can see a chip that is running machine learning algorithm. So this one is nice because we decapsulate the chip to have better signal, and from it we can steal the architecture of a neural network. And finally, a more generic depiction of side channel attack setup that we use when we use deep learning. And in the afternoon I will talk much more about that aspect. So just to conclude, today AI is definitely a gold mine for security and privacy research, which means we can use a lot of different AI techniques to make systems more secure and private. But there is also the other way around, where we can use many things that we know from the security and privacy to improve machine learning AI systems. And there are, luckily for us, there are many successful examples where AI achieved results not possible with other techniques. So we really improved state-of-the-art based on AI. And finally, just to mention, AI is a tool that can help, and we use it to help, but that tool also opens new challenges, which is on its own still nice, because those challenges also need to be solved by us. So that's all from me. Thank you.
안녕하세요. 저는 말레이시아 사람이에요. These are the two things I know in Korean. I cannot speak any more Korean. So, good morning, everyone. I'm very happy to be here. My name is Wai Kong Lee. Just now, I always joke with my friend, if you don't remember my name, you remember King Kong, you remember Wai Kong, okay? So, I'm from Malaysia. So, I was a Ga천대 postdoc Paksahu. So, from 2020 to 2023, just the COVID period. So, I stay inside this boring campus. No, it's not a boring campus. It's actually a very wonderful campus, very beautiful one. So I did a lot of research here, and I'm now an associate professor in Utah, Malaysia. So this is my campus. It's a very beautiful campus with a lot of lakes. Okay, so I want to briefly introduce my research area. I basically work a little bit similar with the Professor Stefan Pichek. So he presented some hardware work. So I do not do the attack, I do the defense implementation. For example, I focus a lot on GPU, on the cryptography engineering. So I implement a lot of algorithms on the GPU. I also have many projects, implementation on hardware, architecture on the FPGA. So if you are from electronics engineering, you should know what is FPGA. So I love to work with that. So I also did some research on the AI. AI not for the training, not for the LLM model. I work on the tiny ML. How to compress the AI model from very large into very small one, and accuracy is still good. So this is what I'm trying to do. In more specifically, I did the quantization techniques. I used the quantization techniques, and we try to improve that. And you can see that some algorithms named here. And to summarize what I did, I can say I do GPU of everything. You have Internet of Things, Internet of something, Internet of everything, but I do GPU of everything. I love GPU. So I also did other algorithms. For example, there's a project doing circuit simulation. You have a large circuit, all in matrix. So I do the simulation using GPU, much faster. Then recently I worked with the quantum annealing. This is a project with the Taiwan University from Taiwan. So they want to implement the search algorithm in on the GPU itself. So just one flavor for your understanding. One of my students did, he combined the crypto accelerator together with the CNN, tensor core. So we create a small mini tensor core, we call it crypt tensor. So this is actually a work. You can do polynomial multiplication on the encryption side. You can also do the CNN at the same time. There's also convolution. So this is how I work with my student, one of the flagship project. Then nowadays I also doing a lot of work on the AI and cryptography and GPU. So because AI is everywhere. Then the one that I want to share today is fully homomorphic encryption. So some of you may not know what is that. It's actually a very fantastic way to process data. You encrypt the data, you send it to the cloud do some computation, but the cloud doesn't know what is this data. It's random data. Nobody knows what is that. So your data privacy is protected, but it's sent back to you, you can decrypt. Other people doesn't know what is that. So it's a very good things, but it is very slow, super slow, like 1,000 times slower. So we need to use GPU or even the hardware to accelerate. Okay, so that concludes my, and there's no Q&A. Okay, sorry.
Hello, good morning everyone. My name is Guangdong Bai, and similar to Wei Chung's name, and the easy way to memorize my name is, it is the same spelling as the Guangdong province in China, which is very close to Hong Kong, but different character. Okay, so the Guang is the light, and Dong is the winter, if you know something about the Chinese character. So I'm from the University of Queensland, Australia. It is located in Brisbane, a beautiful city in the east coast of Australia. So my research is kind of bi-direction. One is from security privacy for AI. Basically, when we use AI systems, how we can guarantee they are secure, they are reliable, and also they don't leak the privacy of user. And the other direction is using AI machine learning for security, and this is related to what I'm gonna introduce briefly today. Use machine learning for the privacy compliance in software. This is a background of my research. Basically, every day we use web and we upload our information to a third party like Meta, to Gmail, and we are very curious whether those even major companies can protect our data well, and the security of our data and also our privacy is a big concern. So fortunately, many countries have put in place the security or the data protection regulations, like in European Union, the GDPR, and also in Korea, we have the Personal Information Protection Act, PIPA. So under this scenario, basically those major companies, if they want to collect user data, for example, if we create an application want to use the user data, we need to provide a thing called privacy policy. In this privacy policy, the developer need to declare what kind of data they will collect from users and how will the data be used for what purpose, and also other information like how long the data will be kept with the developer. And my research is going to check this. Number one, whether those declared information comply with the law, the regulations. And the other direction is between the policy and the actual implementation, because the developers can declare something looks very good, but actually implementation, they can do something malicious, right? So this is the research of the line of research in this direction for my team. So this is something I used to introduce my team. Basically, we have a framework developed for using AI machine learning to evaluate the privacy compliance, and we apply it to different ecosystems like IoT or web-based application, mobile, or the virtual personal assistant applications. And this is not an updated one because recently I have collaboration with Dr. Jason Shear's team on this aspect. So besides that, we have collaboration with other universities in China, in Singapore. I quickly go to one, which is on a virtual personal assistant application. So I believe you use this one is the Alexa skills. I'm not sure that you heard of that. So it's some applications you can invoke from a smart speaker. So if you have a smart speaker of Alexa, you can just use such a verbal command. You just say, Alexa, open particular application for me. Then you can have conversation with those applications. And also, of course, during this conversation, the application may ask your sensitive data. Like it may ask what's your birthday and where is your location. So what we do is we look into those conversations, we use AI to automatically interact with those applications, and meanwhile we check whether the behavior of the application really comply with what they declared in the privacy policy. Okay? Okay, so that is all about my research, and thank you.
Hello everyone, my name is Hammond. You can remember my name because it is just Hammond, so it's very easy. I am currently at the University of New South Wales, which is in Australia, and previously I was at New York University as a research assistant professor, and then before that at the University of Auckland in New Zealand, which has the best flag. So my research area is really looking at AI and design, as well as AI and security more broadly, which is to say the new types of AI, large language models, ChatGPT, Google Gemini, Llama, these provide new opportunities for us to interact with computers and the processes which are running on those computers. And that means that we can change how we also do design with those computers, not just writing and poetry and art. All of my art is AI art, but how we actually design things as well. So in general, I sort of have these three pillars in everything that I do in this space, which is that I want to be able to accelerate the design process. This means that we use tools like ChatGPT to help us build things faster, to make us more productive. Probably the best commercial tool in this space is GitHub Copilot, if you've heard of that or used that. This is a tool which, helps you write code. And I'm very interested in knowing what other tools we might be able to build in this space too. Another area is to democratize development, or to make it easier for everyone to be able to build things. As I showed, I am not an artist, but I can have these beautiful pictures in my slides. And that is because AI now is enabling me to be able to make nice pictures. So wouldn't it be nice also if AI could enable me to do other things that I couldn't previously do, and for you to be able to do things that you couldn't previously do? And then finally, in the security space, just as we are now able to make more things, we should be able to make those things better. And in this regard, we're interested in the security of our designs and how to make that better. So I have done a lot of stuff in the hardware space in particular, and hardware design, but also in security as well. So looking at how do we make computer chips using AI, how do we evaluate if AI is emitting bugs, how do we have ways to find things using assertions, and looking at things like side channels. One of the flagships that we did in our group was we designed the world's first chip, which was actually made using ChatGPT, where ChatGPT wrote every line of code that ended up being used in the design in the hardware description language. And this was taped out and is now actually a chip that functions and works, and I used it to control the lights on my Christmas tree last year. And so in that security space, you know, we're very interested in not just design, but also on helping us find and repair bugs in our designs. And so, you know, we can do that through things like generating assertions, generating tests, and overall, just to conclude those three pillars again, is looking at how we can accelerate design, democratize development, and improve security. If this sounds interesting to you, please add me on LinkedIn using that QR code. We do have places for students. Ooh. Thank you very much.
Hello everyone. So my name is Xinliang Yuan. So currently I'm an associate professor at University of Melbourne. So I just joined the University of Melbourne this month, actually. So very new to there. And before that, I was a faculty member at Faculty of IT at Monash University. It's also the Australian university, which is located in Melbourne. So I got my PhD from Hong Kong, City University, Hong Kong. And before that, I also worked as the software engineer for a company called Stormsys. So basically, this company is making hardware emulator for legacy servers. So I'm not sure if you've heard of like Alpha server, Spark server. So this is very like something is older than Intel and ARMs. So because those servers are not manufactured anymore, so basically some enterprise still need some software emulation to make sure that their legacy software can still operate. So it's very interesting, and also at that time, so I feel that the computer system is very important and very interesting. So that's also why I decided to pursue a PhD in that area. So and also here I just briefly talk about my research interesting. So my research goal is basically to build secure and trustworthy network systems. So it looks like it's a very, it seems very broad, right? Because nowadays, like all the information, your data is digitalized and the system is also digitalized. So, but probably at the very beginning, people or developers, they don't consider security by design. So then there's lots of like attacks and vulnerabilities there. So for example, if we consider a database, right? So you know that the data breach happens every day, I think right now, because that's why the security is not the first priority when you design the database systems. So my first research topic is called encrypted search. So this can be considered a set of cryptography protocols that can enable database to query over encrypted data without decryption. So in that sense, even if there's an external attacker that can somehow steal the database images, so basically they don't have the key to decryption, so they see only garbages, right? So the key challenges for this area will have like two aspects. The first is to enable rich queries, rich functionalities, trying to preserve the functionalities as the clear text systems, right? So while also achieve the good security and the efficiency goals. Okay, and on the other hand, there are also the trade-offs, right? So because we all know that the security is never free. So if you want to have like highly efficient systems, so then you may end up with some low security the protocols. So in that sense, the attacker may still find a way to compromise the systems. So that's why I'm also interested in the second direction, so the attacks and the defense against the encrypted search. So this is also probably the most challenging direction in this field. Okay, so the second direction is more on the network security. So I'm interested in building secure network functions. So what is the network functions? So if you took some like network courses or network security courses, so you probably heard of software defined network, right? So or a virtual network function virtualization. So it means that in the network, it's not just about routing and packet forwarding. You still have like a more advanced function like intrusion detection, traffic engineering. So all these things is beyond of the traditional routing functions. So but right now, because for example, software-defined network, they somehow centralized those function execution into one single place, or maybe even deployed in the cloud environment. So then, well, it will raise some security and privacy concerns. So for example, and also in another hand, right now all the traffics are in the encrypted form, right? So the end-to-end encryption is everywhere. So how can we enable those advanced network functions over the encrypted traffic is also a very interesting direction. So we had a lot of efforts, for example, to enable deep packet inspection, network measurements, and even right now content moderation for encrypted traffics and end-to-end encrypted applications. And the last part is trustworthy machine learning. So this is also a very broad topic. So, but my interest is more lies in the privacy part. So, for example, I'm interested in like design applied crypto protocols for privacy-preserving machine learning. So, just like the Professor Wai-Kong Lee's talk, he's interested in fully homomorphic encryption. I'm also have similar interest, but using different techniques. For example, secure multi-party computation, and my interest is on the graph neural networks. So because graph neural network is also widely used in different applications. So specifically, I'm interested in privacy attacks and defense. So privacy attacks is more like model extraction and membership inference. So it's like the user can query the model from the machine learning and the service platform, but from the query result, they can somehow trying to recover the information of the models and all the information, private information of the training data. Okay, so basically that is it all for my research interest. So if you're interested in any of those directions, you can find me through the email in the previous slides. Thank you.
Okay, you can see this height maybe it's more friendly to male. Okay, because someone can do it this way. Yeah. Okay. Yeah, that's fine. Thank you. Well, yes. Good morning, everyone. My name is Xiaoning Du. I'm from Monash University, and actually, Xingniang is just a previous colleague of mine. Actually, today I'm very happy to be here and give this kind of very brief introduction about my research. And first of all, I would like to say that today I'm very happy to say we have a very good gender balance for this event. I see a lot of girls and female researchers in this room, which is great. And I believe in the future we will have more female researchers come to the stage. All right. So as you can tell from the title, the major goal of my research to make the code intelligence responsible, which means, okay, I want to make them more usable and reliable in the real world. And also thanks to Harmon for the introduction of GitHub Copilot, okay, which is the major system I focus in my research. Okay, so a little bit background about myself. So before joining Monash as a lecturer, I did my PhD and postdoc at Nanyang Technological University. Okay, that's why I know a lot of Singapore friends who is also in this event with us today. And actually before that, I received my bachelor's degree from Fudan University. Okay. And my major research interest, if I can explain it maybe in a better way, is that it's about the intersection of code intelligence and cybersecurity. Okay, so actually for this research scope, I do both intelligent software vulnerability detection and also the security of code intelligence, targeting on the system itself, the data used for training of the large code models, and also the model itself. So actually sometimes when people ask, okay, are you doing this kind of research on AI for software security or software security for AI? I would say, okay, it's really hard to answer this question when AI model is able to generate code. So which means you are doing AI for security, software for, AI for software for AI. Okay, software security, which is really confusing. All right, so now I would like to explain this kind of research scope in more details. Actually, for code, okay, it's kind of a very similar representation as natural language, but actually there is a very important difference between them. Is that, okay, actually we represent semantics in a more rigorous and finer way with code. Okay, actually this kind of different representation also brings a lot of challenges and research opportunities. I can give a very simple example. When we talk about the adversarial attack, okay, actually for natural language, we can develop this kind of synonyms for a word and see, okay, whether we can attack the model or not. And also, even though there are some kind of spelling errors in the word itself, okay, we say there are still some kind of natural errors can be made by humans. But actually for code, for this kind of adversarial attack, you can think about it. If you change any kind of semantics, or you make the semantics really awkward or kind of strange, this kind of perturbation can be easily perceived by humans, right? So that kind of difference, we try to fund this kind of research opportunities and say, okay, how this kind of large code models are, say, made reliable and safe in usage. We identify that quality. We identify these kind of problems focusing on either the dataset or the model. So actually, considering this kind of new challenges, we look into the dataset quality issue and also the dataset copyright issue. Actually, those kind of topics are both related to this kind of very special challenge we faced when dealing with code. And also regarding the model, okay, we look into the robustness of the model itself, which means actually for code models, we need different kind of techniques. We want to evaluate the model robustness against this kind of minor perturbations, and also how we can explain the models themselves. Actually, as a researcher with software engineering background, we would like to say how to represent the knowledge or the behavior of the model, okay, in a more transparent way. Like we can try to represent the model if they are, say, still with a decent, say, size. Okay, so we want to represent the knowledge there with state transition machines, so we can have a better understanding of what's been learned. And another thing is to looking into the energy cost of the system itself, because actually for code as a kind of a very different representation, we rethink the grammar and the format used to represent code, and think about maybe a more concise and compact way to represent the code, so that we could have a better efficiency and eco-friendly code generation design. And of course, more importantly, how this kind of code generation systems can be affected by the user feedback and try to, which allows the attackers to manipulate the system output. Okay, I think that's pretty much all about my research. So if you're interested in any of those, you could easily find them on my homepage. And I'm also very open to discussion and conversion. All right, thank you.
Good morning, everyone. So my name is Raymond Zhao. So I'm also working in Science Data 61, the same institution as Dr. Zhesheng Xue. So because my major is less intuitive to understand, so maybe today's focus, my focus, to make sure that even a layman can understand my major. So by the way, the major is a Korean English word I just learned in the last few days, because usually when I ask a Korean researcher, what is your research area, they usually told me about their PhD supervisor or their research lab. So I need to ask about what is their major to know what kind of research they are doing. So okay, to understand my major, so first I will ask you a question. So if two people, Alice and Bob, they never met each other before, how could they communicate securely? Well, you may have heard about some technology like the encryption. Yes, you definitely can use encryption to encrypt the communication. However, the problem is that if you want to do the encryption, both Alice and Bob, they need to have the same key, right, in order to make sure that the data can be decrypted correctly. Then how could they have the same key if they never met, never talked before? Well, there are some techniques called key chains. So by using key chains, Alice and Bob can have the same shared key. Then they can use the same key to do the data communication, encrypted data communication. So here is an intuitive example. So basically how you do the key chain. So basically, Alice and Bob, they can choose their secret color. For example, Alice chose red and Bob chose green. And then they mix the secret color with some commonly known color, for example, yellow. Then Alice mixed red with yellow, then she got orange, and Bob mixed yellow and green, and Bob got blue. Then they changed their mixed color, and so now Alice got blue and Bob got orange. Then they mixed the received color with their own secret color, so both Alice and Bob got brown. Right, so basically now they can use this brown color to do the communication. So in the real world, basically this kind of colors, they are just some big, very, very big numbers. And then how do you mix them? You need to use some kind of mathematical formulas, because you need to make sure that it is hard for someone else who can see orange and who can see blue to deduct that, for example, if someone else see Alice stand orange, then you need to make sure that that person cannot know Alice actually obtain, Alice actually have red as the secret color, right? So basically, you need to use some kind of mathematical formulas to mix the different colors, to mix the different numbers. Because everyone knows math is difficult, right? However, in 1990s, one of the excellent professor, his name is Peter Shaw, he discovered some algorithms to actually solve these hard mathematical problems efficiently if you have a quantum computer. So although, now basically no one knows what the quantum computer will look like, right? However, some information need to be more secure, right? For example, some classified document in the government. So, for example, you don't want the attacker to be able to crack your secret data in the basement, right? If they actually have a quantum computer there in, for example, 2030. So, so because the quantum computing is actually a threat to this kind of key change techniques, so in 2017, NIST, which is US standardization organization, started to do this kind of standardization process for a new kind of cryptography algorithm called PQC, which is post-quantum cryptography. So this basically there are some new ways to do this kind of key change, so that they can still be secure against this kind of quantum attacks I just introduced on the previous slide. So basically, NIST has already published their PQC standard in 2022. So now basically the task, the mission is basically every existing applications, for example, every website, every mobile phone app, they need to be updated to this PQC, right, in order to be safe against quantum attacks. And also, like, for example, your mobile phone, every device, they need to support PQC, right? Like your mobile phone, your web browser, they need to be able to run this kind of PQC algorithm, right? So basically, everyone needs to migrate to quantum safe, right? So basically, my research is about how to efficiently and securely implement all the different kind of PQC algorithms in different applications and on different devices. Yeah, so hopefully even a layman can understand what is my major after I give the talk today. Yeah, thank you.
Good morning, everyone. My name is Feng from University of Melbourne in Australia, and I think the last for the first part of this event. First of all, I want to thank all the organizers. I think it's a very great event, and I also learned a lot from this event. Okay, I will start introduce my research. It's mainly related to trustworthy machine learning from a statistical view. Currently, I'm a lecturer in machine learning at the University of Melbourne, and luckily I previously got NERSC Outstanding Paper Award and regarding all detection shift theory. And currently, my research interests mainly about the statistical hypothesis testing and all stuff regarding distribution shift. And for the statistical hypothesis testing, focus on the two-sample testing or independent testing to say what's the distributional difference between two set samples, and providing a very useful statistic for the following machine learning tasks. And for distribution shift, it's more often related to the trustworthy nowadays. It's currently I focus on the adversary shift, OD detection shift, OD shift, and the nature shift. For the adversary shift, we mainly want to develop algorithms to defend against adversary shift. For example, we want to develop detection algorithms to detect that, or we want to train algorithm to robust that, or purify the upcoming images such that we can do the good tasks for the classification. And for the OOD shift, and we first, of course, we want to detect OOD data. We don't want our algorithm to say something they don't know as predict something they don't know and as something known. Or we want to generalize well to some unknown styles. For example, we want a model trained with daylight images and adapt to the images taken at night. Okay, something like adaptation. And for nature shift, it's more nature happens in the current machine learning scenarios. We want to develop algorithm to adapt to the new scenario, or we want to transfer the knowledge from domain with rich data to the knowledge with to the domain with the field data. Okay, it's transfer learning. Okay, I will briefly introduce three kinds of shift in my research area and research interest. First is adversary shift. I think a lot of you know this well-known image. So in adversary attacks, we want to add this very small perturbations. For example, the noise image in the middle to the panda image, and we got a new image, right? For this new image from our human eyes is still panda, but yeah, for the classifier, well-trained classifier, previously this image will be predicted as panda, but after we add this noise, its classifier will predict this image as other animal given, okay, with a very high confidence. So that's an adversary attack. And we want to against this kind of attack, okay, either by train model, like robust to adversary attacks, or we want to detect this example before we use our model, or when we want to use the classifier, we want to purify the left image, okay, and get the more clean, adversary meaning clean image, and fit that image to the model, and we got prediction. Okay, that's the adversary shift and how we handle this kind of shift. Another one is called out of distribution shift. Okay, considering now we have the self-driving system and we're driving cars, and for this kind of system, we want the system tell us something unknown, okay, on the road, instead of predict all the things as known objects, okay. For example, for all the machine learning algorithms, we are trained with some given objects and classes, okay. However, in the real world, we often meet something unknown, okay. So we want the algorithm to tell us what it does not know, okay. It will be very helpful in this kind of life critical system, okay, because we don't want to the system recognize some like the rock on the road as a stop sign, okay. That's as a stop sign. Stop sign is a good one. As for example, it's just some speed sign, for example, 100 kilometers right per hour. Yeah, it's not good because it will because it's self-driving and it will cause the life loss. Yeah, in the worst case. The last one is a nature general shift. It will happen in our recent life. A well-known example like here is that here is a segmentation model. Segmentation model means that we want to segment all the things within the image to different categories, okay? And how could we do that? One is very simple, like the normal machine learning algorithms. We just take images and we let human beings to annotate these images and train a model, okay? To classify each pixel within one image, okay, to its corresponding classes. It's called segmentation. However, this labeling process is, first, labeling process itself is very time consuming. Second, how to obtain these images is also time consuming. So one way in the literature and actually in the industry, we might use the images or scenarios from a game, okay? It's GTA 5 is a game. Simulate the normal life, although it's not a good game sometimes as a player, okay? Yeah, but we can use the images taken from the game and train a model and transfer the corresponding knowledge to the real world, okay? So it's a well-known case about transfer learning, and here we want to leverage knowledge from domain we can easily get, or whose label can be easily get, okay, and train a model based on that and transfer its knowledge to the real world, okay, to the real world. It actually has more scenarios, except for just image segmentation or classification. For example, in physics, we have many simulations, physics image simulations. It takes time, takes a lot of time, okay. So if we can just use the machine learning model, try to approximate this kind of physics simulations, it will be very, very helpful, okay. But one thing we need to think about is that there will be a distribution shift, okay, between what we simulated. Here is what is taken from the game, okay, and what we want to apply is in the real life. There are distribution gap, okay. So how could we minimize the negative effect brought by this distribution gap is very important. And that's also actually the motivation during my PhD, why I want to develop or dive into thermal testing is a kind of technique to provide the statistics to say the difference is a distributional difference between two subsamples. Okay, it's a very important one, yeah, in the machine learning models or algorithms. Okay, that's all for my research. Thank you.
So hello everyone. I think these 9 international speakers use very hard words that I just got to understand three days ago, like quantum attacks, like FPGA, like homomorphic encryption. So if you don't know these words, it's all good. So yeah. And then last but not least, as the last speaker, I'm Jason, and a senior research scientist at CSIRO and team leader of AI security, and I want to introduce you to something fun. There's no bizarre words or keywords there that I mentioned, which is easy for you to understand what we are doing in the real world. The real world now includes not only physical world, but also digital world, okay? So I introduce a little bit about our Australian Science Agency, and this group, which I am in, is the Cybersecurity and Quantum Systems. And in this group, we have 5 pillars. For example, AI and cybersecurity, data in the real world, AI for science, quantum technologies, and humans and machines. And we have around 130 staff, including postdoc, doing research in our CSIRO Data 61 group. And you can definitely see these students and the visiting students as well. So I think the diversity of our Australian scientific agency is pretty good. I think more than 30% of the staff, including postdocs and the students, are female. So we strongly encourage the female students coming to Australia to study, to visit, and to exchange your experience, and then to learn, and then you can learn what you want to learn in Australia, and then come back to Korea, and then to exchange the academic things. Okay, this is the good way that we want you to do in the future. So, and this is the, you can see 3 nice pictures taken from different sites across Australia. The first left-hand side, leftmost side is the picture taken in Clayton, in Melbourne, and the middle, the picture in the middle was taken from Adelaide side, and the picture taken from rightmost is from Sydney side. So you can see we have distributed agencies across entire Australia, and then every site has these AI and cyber data in the real world, these pillars. Not only one site focus on one pillar, no. So every site has different diversity of research, directions of research, okay? And this is the benefit that you can get when you come to Australia. And then what I'm doing is very easy. I'm trying to do attacks and trying to let the common people, like let the students protect yourself from stalking, okay? This is a very important and very critical research area that every student can start from scratch, okay? So People Nearby service is kind of a location-based service in WeChat or in maybe Kakao Talk or in Kakao something similar in Korea. So every student may use this, but the students didn't know if you query the People Nearby service, there's some possibility that you can be stalked. You can be pinpoint where you are. And this is the important thing that I have done a systematic research along my PhDs. So for example, I take an example in WeChat. So WeChat reports distance, like Alice and Bob, right? When Bob wants to know where Alice is, and then WeChat only shows that Alice is 500 meters away from Bob, which means Alice is in the circular band, dotted shown in green. So there's some random error there to protect Alice where she is. Then my methodology, my research is trying to pinpoint, trying to localize where Alice is. And then if you put many of the fake GPS, fake probes along the geographic area, like Seoul, like Gacheon University, you put all these dots, fake GPS, fake probes, and then with large measurement, you can pinpoint where Alice is. For example, you can see that Alice appear around the Gacheon University at 10 o'clock, and then and at night, and she probably does some lunch, does some dinner in where she lives. So then the residence of Alice is exposed to Bob, right? So this is a very serious problem, and this is what I did for my entire, for the early career of my PhD, and then Friday as well. So my research concept and philosophy is I try to break things in the real world, which includes physical world and digital world, and then trying to find protection and the defense to help the common people and help the students and minorities to protect themselves in this area, especially in the era of AI. So thank you very much. So now I think let's move to the next session, and I hope all the speakers can be seated at the panel in the front. And then we will go for Q&A. So I think all the speakers now be seated and they are prepared for the question that you want to ask. So any questions? So I think this session will start from research methodology discussion, because the panelists across this panel have different research methodologies. And for example, Professor Pisek usually focuses on mathematics and the theory stuff. And Professor Bai also is a theory guy. And Raymond and is a kind of a quantum stuff, and this different kind of theory, and even without real-world study, right? Because human quantum attacks and quantum machine is not feasible in the near term. And then Xiaoning and Hammond, they are focused on empirical studies, so which is totally different from theory. So I would like to maybe query Professor Pisek first. So what do you think? How do you balance your theory and the practical studies? And what's your opinion on that?
Okay, thank you for a nice question. It's not so easy to answer. First of all, I also do a lot of stuff not connected with theory at all, so just to be clear on that side. Yeah, it's always tricky. I mean, when you work in something that is interdisciplinary, which basically most of us do as intersection of AI and cybersecurity, you always have the problem, what's the right measure? Do you emphasize more AI? Do you emphasize more cybersecurity? And how do you approach the audience? Because it's not the same if you talk about security to AI people and if you talk about security to security people, and vice versa. So you need to know your audience. You need to know your use cases. Just as an example, when we talk about security, we are much more interested to put it in a proper perspective, proper threat model, and hopefully some realistic application. When we talk only from the AI side, we are maybe more interested that it simply makes sense that it can work. Whether it would be used in such a way in real-world application, that's different. So I would say there is that always trade-off to know the audience.
Yeah. Okay. So Raymond, so do you want to comment on what Stepan said, like theory and practice, and because in your area there's no machine there, so how can you deal with this kind of study? Do you think if the machine is feasible, or do you think if your object of your study cannot be
put into practice in the near future? And then what's the meaning to or significance to carry out your study, for example, quantum?
Yeah, so that's a good question. So, because, yes, as Jason mentioned, we don't have a quantum computer yet, and we don't know what a quantum computer will look like, right? So basically, if you want to do research in quantum cryptography, you need to use simulations. Basically, you need to use some simulation tool to basically to test your theory, right? And by the way, I think my research is focusing more on the post-quantum cryptography. The post-quantum cryptography is actually a bit different from quantum cryptography, because post-quantum means that you can actually run them on your current devices, for example, on your laptop, on your mobile phone. So basically, my research is also more about bridging the gap between the theoretical research and like the industry, right? When you then need a product. So because my research focuses on how to implement those POC, right, to make them practical, right? So yeah, so I think that's all from me.
Okay. So thank you, Raymond, and. So Guangdong, so I think your research methodology is in between, balancely between what Raymond is doing and what Pesek is doing. For example, you're using formal method to study the AI models and AI algorithms, but these AI algorithms can be put into practice in the real world, right? So how you choose your research methodology to using theory to study the real-world object?
Yeah, thank you, Jason. Great question. So basically, as scientists, we don't like uncertainty. We don't like something like just empirical. We can say from experiments, we observe this. And mostly we want to find a kind of foundation, a formal foundation for what happened, so that we can explain and we can like communicate with others. Like we have strong confidence because using a formal way or mathematical way, we can prove like this AI model will never act maliciously, will never act in an incorrect way. So mostly we, in my research, we look into this, say for a particular algorithm or a particular protocol, like Raymond mentioned, how we can use mathematical way, different mathematical tools to guarantee when we say this tool, this algorithm is secure or is correct, we have some mathematical evidence. So that is what we are pursuing for. And on the other hand, Jason also mentioned it's quite challenging because mostly just now Professor Feng Liu also give you an example, right? We want to make sure AI model, the automatic driving system, will not recognize some traffic scene in a wrong way. And how we can do that? Usually, still remember his panda example. The attacker might put some perturbation, right? That cannot be seen by human, but maybe taken wrongly by an AI model. So we want to prove this, and we want to make sure, if the attacker's perturbation is within a range, then eventually we can say, okay, our AI model will never recognize this traffic scene in the wrong way. So in reality, unfortunate thing is, if we do it in a mathematical way, usually that perturbation is too small, and we don't have any way to stop the attacker from using some advanced techniques, right, or some arbitrary behaviors on the traffic side. So that is why the other aspect, as Jason mentioned, is we also want to look into this problem from empirical perspective. Basically, we use testing, like we generate random thing and give it to the AI system and see how it perform on those random inputs. So you can say, basically, as a summary, we kind of try to dig out, try to go in deep from the mathematical side to provide the formal foundation for those AI systems we rely on in our daily lives. And on the other hand, we also are using those empirical ways, those use the capability of the computer in generating random things to test those systems, so that we can kind of meet in the middle to eventually towards a more reliable, more trustworthy AI world. Okay, thanks.
So thank you, Professor Bai. So Professor Bai just mentioned AI safety, AI trustworthy. And I think in autonomous vehicles, there's a perfect debate around whether we should prioritize the safety or whether we should prioritize the AI development. I think from the talk, as you saw just several minutes ago, Fen Liu is the expert in computer vision and the autonomous vehicle segmentation tasks. So I'd just like to invite Fen Liu to give some 2 cents about what do you think the priority between the AI safety problem and AI development problem.
Okay, yeah, I think that's a very interesting and important question, and not easy to answer. Yeah, my research starts from the transfer learning. It's like we want to transfer knowledge from a domain with rich knowledge to a domain with a few knowledge, and then go to the testing, and then find the adversary attacks. It's a kind of distribution shift problem. Yeah, so it's how I started the trustworthy machine learning research. So in my sense, I think trustworthy machine learning is important, but we need to specify the threat model and what's the scenarios we want to take care. Yeah, we want to take care. And for AI development, there are like 2 opinions. I know one is just saying, like for example, ChatGPT is still not that powerful. So they want to make it more powerful and make it more, can be utilized in more and more scenarios. Another opinion is like we need to regularize this kind of tool and to avoid a lot of things. Yeah. Personally, I think the regularization is very important. Yeah, regularization is very important because we can do a lot of things with AI models. And at the very beginning, I do not understand why OpenAI became closed AI. But now as more and more I understand that, because for general model, perhaps at the very beginning, at least some human government is important. Yeah, otherwise for the general model we can do it for a lot of bad things. Yeah, so I think regularization is important. Yeah, regularization is important. And how to set up this kind of regularization, for example, policies, I think we do need to understand the models, like what Professor Bai did for the verification for the neural networks, and what's the certification for a lot of attacks and the defense is very important. Yeah. So in my opinion, I think the certification is study this kind of thing, models, AI models from theory is very, very important currently. Yeah. And to not eventually, it's like at least we start to know what's the boundary for the AI models, and yeah, that's very important in theory. Yeah. Otherwise, we might, if there is no guidance from theory, we can try, right? We can try by experiments, but first it's kind of I would like not to say it's kind of random searching, but definitely it's not gradient descent searching, gradient-based searching. Yeah, if we have theory, we can do some gradient thing. Yeah, it's a much faster. Yeah, so we can guide the models and make some regularization for the AI models. Yeah.
Okay, thank you, Fen Liu. And because you just mentioned also the what OpenAI is currently doing is kind of very off the academic track. So because it becomes closed, and how can we academics do the research in the future? And I think Harman has a close relationship with OpenAI in some collaboration. And then Harman, as empirical study guy, and what do you think of this issue, AI safety and development, according to your own research experience?
Yeah. So for me, I am very empirical. I like to know the applications of the domains in which the various AI are being used. And one of the most interesting things to me comes to the implications of what it is the technology enables. And this is something that is a little bit tricky to answer from a theory point of view. You know, a theory can tell you all about the insides of a large language model and can tell you about hallucinations and various mistakes that they can and will make. But it's the empirical side, the application and the implication side, which is where we can actually look at the consequences of the theory that are, you know, that are more interesting to other researchers. So for me, it's the kinds of things where a language model emits a bug. The theory can say, yes, it will emit a bug. But it's the application side where we say, what does that mean? Why does it matter? What are the consequences of it when someone emits a bug or a language model emits a bug? And we can take measurements of users in the real world where it says, you know, someone might say, well, it doesn't really matter that the language model emits a bug because humans emit bugs. And we go, okay, but who emits more bugs? What happens if we combine a language model with a human? Is that an even worse situation? Do they feed off each other's worst impulses? So yes, from the empirical side, I'm very interested in knowing those kinds of implication questions and the downstream consequences of decisions and results that happen in the theory world. From a sort of safety point of view and the OpenAI side of things, I also feel it's a bit of a shame that OpenAI stopped releasing as much as they did in their early days. But fortunately, there are other groups which are releasing open models of relatively high quality. So at least there are still, you know, relatively open spaces in which we can do things like with the Llama models and the new ones from Google called Gemma. And of course the various other organizations like Anthropic and so on that choose to make open models too. So yeah, hopefully that sort of answered the question.
Sure. Thank you, Hammond. And Xiaoning also is an empirical lady. And so what's your opinion? And do you want to champion your empirical studies in terms of the responsible AI study? Yeah.
Well, yes, I am actually either for empirical studies or this kind of more engineering considerations to say targeting the AI systems and large language models. I believe we try, instead of to looking into the state of the art, we are more interested in the state of the practice. Okay, so what does this all kind of theory mean in practice? And I think this is very important because no matter whether we understand the inner mechanisms of large language models and large code models, they are being used every day. And you can imagine the subscriptions to Copilot nowadays and how they are changing the way we develop the code, and also say the portion of the code in this world that are developed by machines, and and then compared to than humans. I think this is a really important thing to even we cannot find a very efficient or very effective solutions at the moment, but we need to understand the problem in the first place. Yeah.
Okay. Thank you, Xiaoning. So, and Xin Liang, as you saw in his slides, so he has working experience in a software company in the United States, and now is the associate professor at the University of Melbourne. So, Xin Liang, my question for you is, when you're working in a company and when you work as associate professor, as a professor at the university, so when you teach your students, or your PhD students, which direction they should focus, and what's your methodology for teaching and coaching, for training the PhD students?
Okay, so that's also a very interesting question. So I think probably some my personal experience. I mean, because I have been working at industry, so I think the job is somehow very interesting because it's related to R&D, research and development. So we design product and algorithms. So it's kind of like very interesting because every day you somehow sort of like tackle new problems and not just writing the code, I mean, in a tedious way. So, but the reason I think I want to pursue PhD is that I feel that in the long run, maybe research is probably more interested because you can learn like a lot of new things like every day. So you can polish yourself. You can somehow find out you can learn out of new friends from different countries and very good researchers, just like those professors here. So, and regarding the jobs in the university, I guess of course, one of the major component is research, right? So you're somehow trying to tackle very challenging problems, and also, but of course, based on your interest, right? This is very important. I guess this is something essentially or like underlying to drive you to work as a researcher or work as a professor in the university. And of course, on the other hand, in the university, you also need to teach. Right, so this is kind of like, it's also good because you somehow spread your knowledge to broad audience, right? So for example, if you learn something very advanced in security or AI, you can teach those knowledge to the next generation, right? So because we all know that in the computer science field, well, the knowledge like is somehow evolved very fast. So you want to deliver the latest, knowledge and technology to your students, and somehow from their feedback, you will feel very satisfactory. So, and regarding the student training, PhD student training, I guess because I designed some systems, so basically it's kind of like also bridge the gap between the practice and the theory. So you have to somehow understand how existing systems works and what are the technologies can be used to somehow redesign the system or improve the security of the system. So you have to consider multi-factors, the security, efficiency, like performance and utility. So how to balance this, how to make a good trade-off when you design the system. I guess this is the most challenging part. And it's also like a very interesting, procedures during the kind of like the research period. So I guess probably that's all for the part. Yeah, but I want to say something regarding to the safety or trustworthy AI, because if you look at all the presentation here, you may find that each of us may focus on the specific aspect. Right. For example, if you look at the phone slides, he focused on the adversary sample, which is kind of like a robustness of the machine learning systems. And I talk about privacy. Right, so this is kind of like a privacy aspect of the trustworthy. And Professor Bai talked about the verification. So this is also kind of like a transparency, auditing of the trustworthy system. And also, in addition to that, there are some other aspects like fairness. Right? You don't want the model to make bias, and also the expandability. You want the model to give you some more information about the prediction result. And even now, because we talk about environmental well-being, so which means that you also want your system energy efficient, right? So to make a good the energy consumption. So, but when you combine those together, so the situation becomes very, very complicated. So, for example, if your system say, okay, you have a very good fairness, but they may somehow the algorithm implemented in the system may increase the privacy risks. So then, how to like really actually consider or prioritize different aspects is also something we need to consider, especially when you deploy it or you design systems for specific user cases. I guess this is something really worth to explore in the future.
Okay. So thank you, Professor Yuan, for his detailed explanation between the practice and theoretical work. So, and then my second round of question is, okay. Next part or okay, research career.
Okay, I will make a short summary on what they have shared on the research methodology. Basically, there are some researchers who are doing the very fundamental work, like maybe Raymond is doing more on the proof of security, cyber cryptography. So they need to go into the mathematics and fundamental, like Professor Bai as well. You need to understand the fundamental. So fundamental is the most important things. So without the fundamental, the research is not solid. So this is one of the key takeaway here.
Yeah, let me speak, translate in Korean because we have many audience, undergraduate students. So that's why I will try to make them understand what they are saying about. Okay? 오케이. 첫 번째로 우리 논의했던 것 중에 하나가 뭐냐면, 물론 여기에는 이제 이론하신 분도 있고 또 구현 쪽에 포커스 하신 분도 있는데, 근데 공통적으로 나온 얘기가 뭐냐면 펀더멘털이 중요하다. 펀더멘털은 뭐죠? 어떤 분야든지 펀더멘털이 있어요. 아주 근본적인 거. 우리 컴퓨터 사이언스에서는 뭘까요? 뭐 알고리즘, 또 자료구조, 또 우리가 펀더멘털 하면 어떤 학문들이 있어요? 수학, 통계학. 사실 이런 것들이 굉장히 중요합니다. 여러분들이 이런 것들을 잘해야지 나아가서 AI도 잘할 수 있고 또 뭐 보안도 잘할 수 있고 어떤 분야에서도 여러분이 치고 나갈 수가 있어요. 그래서 여기서 강조하는 부분이 뭐다? 어플리케이션도 중요하지만 여러분이 지금 학교에서 배우는 부분, 이 펀더멘털, 특히 1, 2학년 초급 과정에서 배우는 그 펀더멘털, 이런 것들이 굉장히 중요하다는 것을 말씀을 해주시고 계십니다.
So to enable the fundamental in your research, maths is something that Professor Bai always emphasized, and I observed that many of the researchers also emphasize the mathematics. So it is a very useful tool to prove your research is really okay, verified. So you have confidence on what you do.
다시 한번 강조하네요. 특히 여러 과목이 있는데 어떤 그런 펀더멘털을 다룬 과목 중에서 수학이 중요하다. 수학을 통해서 여러분이 한 것들을 가지고 우리가 검증을 할 수 있고 또 뭐 아까 말씀은 안 하셨지만 특히 AI는 그 펀더멘털 측에서도 그 통계가 굉장히 중요해요. 그래서 뭐 수학이나 통계는 거의 한 지붕에 그죠? 거의 비슷한 거라고 볼 수가 있는데 아무튼 여러분들이 어렵게 생각하는 그런 수학 통계를 기본을 잘 닦아야만이 여러분이 나중에 어떤 그죠? 어떤 연구를 하시든지 또 엔지니어로 하시든지 어떤 성공하는데 아주 큰 밑거름이 될 것이다. 이런 말씀을 해주셨습니다.
And then when you do the research, there are many different fields. You have your own field. So you have to understand the audience of your field. For example, AI, what are the things they want to know more? Some are more fundamental, some are more on application. So when you do the research, when you pick the field, you have to understand what is the expectation and how it relates to industry, because you need to apply the research result to the industry.
자, 여러분들이 뭔가 발표를 할 때 가장 중요한 것 중에 하나가 뭐냐면 청중을 아셔야 되는 거죠. 청중. 여러분 청중에 기대치가 있어요. 여러분 청중이 왔을 때 여기서 발표를 듣고 뭐를 얻을 것인가. 마찬가지죠. 여러분이 어떤 공부를 하시고 연구를 하시고 학문을 하실 때도 마찬가지입니다. 이게 그 자체로 끝나지 않고 이것이 또 이런 학교 연구계뿐만 아니라 궁극적으로는 어떤 산업계, 궁극적으로는 사회에 적용이 될 것입니다. 그래서 여러분이 개발하는, 연구하는 이런 기술들이 어떻게 적용될 것인지 그런 부분도 굉장히 중요하다라는 말씀을 하고 계시죠. 왜냐하면 사실 학문은 세계라고 하지만 그 학문이 우리가 살고 있는 실세계에서 결코 유리될 수가 없어요. 독립될 수가 없습니다. 그래서 아까도 몇 가지 나왔죠. 우리가 AI 하면 그 AI가 다양한 분야에 적용이 되잖아요. 그런 기능도 중요하고 또 기능만 중요한가요? 그렇지 않죠. 또 그 AI를 사용하는 그 사용자의 어떤 프라이버시, 또 어떤 보안, 시큐리티 그런 다양한 그런 팩터들이 있습니다. 그런데 그런 부분들을 우리가 넓은 시각에서 그걸 보면서 공부를 해야 된다는 거죠. 어떤 한쪽만 치우쳐서 해가지고는 그런 어떤 한계가 있지 않나. 그래서 know the audience. 그래서 여러분이 공부하는 그 기술이 어디에 어떻게 적용될 것인가. 구체적으로 리얼 어플리케이션이 뭐고 또 유스 케이스 사용 사례가 어떻게 될 것인가. 이런 것들도 여러분들이 인식하면 좋겠다. 이런 말씀을 하셨습니다.
Okay, I think the last point, most important thing is that you need to have strong interest when you do research. Like Professor Xingliang Yuan, he mentioned that from industry to academic, the interest is the biggest drive to him. Because in long run, academic is more interesting because you can do something you like to do. So this is the main drive he can be happy when he work on this job. So interest is very important.
네, 알아들으셨죠? 네, 인터레스트. 여러분이 흥미가 가장 중요하다는 거죠. 연구를 하시든지, 뭔 개발하시든지. 왜냐하면 이게 뭐 단기간 끝나는 게 아니라 롱롱 게임이니까. 오랜 동안 여러분이 추구해야 되는데, 여러분이 관심이 없고, 여러분 교수님이 그냥 시켜서 하는 거라면, 네, 그죠? 좋은 결과 나오기도 쉽지 않고, 또 여러분이 재미가 없어. 그래서 좋은 결과 나오기 쉽지 않습니다. 그래서 여러분의 흥미가 무엇인가. 사실 모티베이션이죠. 그 모티베이션을 여러분이 빨리 식별하는 게 중요하다라는 말씀을 하셨어요. 뭐 이거는 여러분이 더 잘하실 것 같아요. 여러분이 직접 해보시면 아시겠지만 여러분이 흥미에 있어서 하면 많은 좋은 결과를 기대할 수 있지만 흥미가 없으면 한계가 있습니다. 그래서 여러분이 하고 계시는 그 분야에서 정말 여러분이 뭐에 관심이 있는지 그걸 다시 한번 돌아볼 수 있는 그런 시간을 가졌으면 좋겠습니다. 그 다음에 이제 아까 제가 좀 메모했던 것 중에 하나가 또 뭐냐면 현실 세계, 그러니까 회사에서 산업계에서 엔지니어로 근무하셨다가 또 학교로 돌아오신 분이 있거든요. 그분이 그 박사과정을 가르칠 때 어떤 것들이 중요하냐 그런 말씀을 하셨냐면 일단 AI는 너무 빨리 변한다, 너무 빨리 발전한다 그런 말씀을 하셨고 그렇지만 그 갭이 있다, 그죠? 이상 세계, 우리 학문하는 사람들이 생각하는 그런 이상 세계하고 실제 세계는 또 격차가 있다는 거죠. 그런 격차를 어떻게 줄일 것인가, 그 다음에 그 격차를 어떻게 밸런스, 그죠? 균형을 유지할 것인가, 그죠? 세상에 어떤 것도 완전한 게 있을 수가 없어요. 어떤 한쪽을 추구하면 다른 한쪽은, 그죠? 좀 등한시하게 되지 않습니까? 그래서 그 서로 상충 관계에 있는 것들을 어떻게 트레이드 오프, 그런 상충 관계에 있는 것들을 어떻게 그 밸런스, 균형을 유지할 것인가, 그런 것들이 중요하다. 특히 박사과정 하는 학생들한테 그런 조언을 해줬습니다. 그래서 일견 그렇게 서로 다르게 보이는 것들, 예를 들면 AI에서 어떤 효율성 있죠. 정확도, 효율성, 성능 이런 것도 있지만 또 어떤 프라이버시, 시큐리티 뭐 이런 것들을 서로 상충도 될 수 있고 그런데 이런 것들을 어떻게 콤바인 투게더 어떻게 잘 조합하느냐 이런 것들도 굉장히 중요하다 이런 말씀을 해주셨습니다. Okay, that's all. Okay, Dr. Zhu, you can move on to next section.
Sure. So we are moving to the second session, which is about the research career. And I believe all of the panelists have PhD degrees, whether either in computer science or mathematics. So, but when they get to the position as they are, the path is totally different. And I hope every panelist can share their PhD study experience and also how they can survive in this competitive, increasingly competitive academia across the world, and share some experience in their own country that you are working. Okay? So I start from Professor Bai, University of Queensland.
Yeah, okay, thanks, Jason. So I had my PhD in Singapore, National University of Singapore. And I think, to me, the most important thing for PhD students is you should keep keeping curious. So always, like just now also Professor Huang mentioned, right, your motivation, your interest, and find something that really you feel you can go deep, and also that can give you the most satisfaction, and then look into that, work hard. And this is something I got from my PhD, and also now when I supervise my PhD students, I also let them know. It's not, so PhD is different from coursework student. It's not like you are waiting for your supervisors to give you the topic or the methodology or design of the experiment, but it's more like you should drive it. So the wheel is on your hands. And of course, your supervisor is going to help you, like if you have any doubt on whether the methodology design is correct, is comprehensive. And this is also the boundary of the supervisor, right? They will not actually interfere like, oh, you should do this, you should do that. So, yeah, I talk too much, but I think in summary is, yes, find something which you are interested and go deep, and eventually the hard work will pay off. Thank you.
Okay. Yeah, I quite agree with what you said. Definitely, I mean, the goal as in a PhD is to become expert in a topic. So that's why you want to go deep. But at the same time, I also feel it's always very interesting to try to go as wide as possible at the same time. Try to see the same problems from different perspectives. So even though you are doing AI, there is the perspective of security if you are doing security in AI. So you do not need to be limited only to one perspective. But that being said, of course, you need to be expert or as close as possible to expert in at least something. In my career, I tried also to see stuff from different perspectives. So I did masters actually in electrical engineering, and then I worked 7 years in industry. So completely different stuff than doing now. Then I moved to let's say computer science. I did what is called double doctorate, so 2 universities. And this is my core work, but at the same time I also enjoy other aspects like mathematics. So I did one more PhD in mathematics on a different university to get different aspect of same stuff. So I do like deep but also wide. Yeah, I think that's enough.
Okay, so as a senior research scientist at CSIRO now, I just share a little bit about my research career. So my bachelor's degree is in pure mathematics, and I study all the real analysis and partial differential equations and algebra, modern algebra, abstract algebra, and everything that's useless, looks like. So, yeah. And then at that time, I think it's 2012, 10 years ago, more than 10 years ago, I met my PhD advisor, Keith Roth, and who is actually the author of the book, famous book, Computer Networking, Top-Down Approach. And then he is definitely expert in computer networking. But he told me that computer networking is over. He said, it's over. Why? He said, the next decade is AI. He said, deep learning will be the leading techniques. And then he said, we should learn together. We should learn together. And then he gave me a book that he never had a chance to read. He said, Jason, you should read and then teach me every week. And then this is when I was the fourth year in China, because Chinese system usually has 4 years in bachelor's degree, but Australia only has 3 years. And then in parallel, I study AI, and also I'm doing attacking problems, right? The WeChat attacking problem, social media app, because this is the first question he wants to test me, whether I can understand the real world question. And then he just bring me the question, and then after 1 week he check what's your methodology and what's the real world thing. And then after everything, he said, okay, Jason, now you start to write the paper. And I said, how to write the paper in a document? No, he said, using LaTeX. I said, what is LaTeX? He said, you can find it online. And then he gave me 1 week to finish the LaTeX, to write the papers in LaTeX. And then I find all my ways, like 24/7 to work on this paper. And then I present to him. He said, like, Jason, sorry, it's unreadable. So your English is unreadable. So then every week, after this draft of the paper, he said, Jason, just pull a chair and sit beside me, and he corrected my English, one word by one word, and saying why he doesn't understand my English. And then he said, writing in English is an essential communication tool in your career if you want to pursue the academic in the future. And then after that, we did a lot of papers and with huge impact. And then he said, you can stay in privacy and security, because he said, whatever the emerging technologies appear, then security will never die. So I think he said this is a very good area, and then he should, you should go straight and forward. And then now he is totally a machine learning guy and doing reinforcement learning. And he said he wants to train more students. And then whatever the students interested in, and then he is very tolerate that the students do not work in the area that he is working on. And I think this is the experience that I want to share. Thank you.
Okay, so very, very interesting experience from Jason. So myself, so I also got the bachelor and the master from different from computer science. I'm in electrical engineering. So my bachelor is more on the telecommunication and signal processing. So I learned a lot of the courses in my undergraduate study related to those two directions. And then later, my master is also electrical engineering, but more focused on the circuit design. So yeah, that's why I also understand a little bit Harman's research areas. So and then when I decided to pursue a PhD, and I think at that time, around 2013, so the cloud computing is very matured. So again, so there are a lot of security issues. That's why I think maybe cyber or security is a very promising direction in the future. So I think because I did my PhD in Hong Kong, so I guess Hong Kong, it's a very interesting place for PhD. So they somehow inherit the UK system. So it's like you have a 3.5 year PhD study, so which is sort of like a very short time. So yeah, I think I started from the research assistant, not the PhD student directly. I worked maybe almost a half year, maybe 8 months as a research assistant before the PhD. And also, but the strange thing is that a lot of the professors in Hong Kong is actually graduated from the top universities in US. So they actually get the training from the US system, but their PhD education is inherited from UK system. So that's something interesting. And also they have a tenure track. And the competition of the tenure track in Hong Kong is, I can say, is extensively intense. So that's why, yeah, so at that time my supervisor is just joined the university. He's an assistant professor at that time. So that's why I'm also his first PhD student. So I think I'm very lucky because he works very closely with me. So at that time, and also with a small group. So I remember the research environment there is very good. So because he is also, junior, and he teach me a lot, hands-on, basically hand by hand, how to like find research problem, how to formalize a problem, how to find the solutions, and even like how to write a paper. Right? So and also in the group, because the group is very small, so the discussion in the group is also very intense. So I still remember that every day I had a lunch with my peers. So we always discuss research questions, even we do different research directions. And sometimes my supervisor also joined the lunch together with the students. So have some very intense discussion. And another good thing probably in Hong Kong is that the location is somehow very unique. So I still remember that every like summer or winter, so a lot of professors from U.S. universities and from Europe, they come to visit Hong Kong, and they deliver seminar talks, to the students, PhD students. So the talks also is very diverse. Topics very diverse. So we learned a lot from all these top researchers from different countries. So we find that it's very, very helpful, because when you communicate with them, right, so you learn what they're doing, and you can explain your research to those professors. They can give you very good feedbacks from different perspectives. And also, when you go to the conference, right, so you can meet them again, and then they can later give you some career advice as well. So this is, I think this is also something if you want to do a PhD, right, so it's kind of like also important. Learn from your senior professors, peers, and so this is very, very, I think it's very inspiring, experience. Yeah.
All right. So actually, I totally agree with maybe everyone's opinions and what you just shared. Actually, I also found it very difficult for me to propose any kind of thing new. So I quickly go through this kind of maybe most important things for us to do research today. And actually I think all this kind of, if you have very good peers, supervisors, and someone to discussion and focus on a particular area and try to dig and to solve this kind of very difficult problem, that's fantastic. But I would say that's kind of too ideal for nowadays. Actually, I think this is a very important lesson I also learned from my PhD advisor. Actually, nowadays, I think money is maybe it's very important, or maybe more important than this kind of research we are doing. Because actually, if we do not have money, we do not have this kind of financial support for our research. We do not have students, postdocs. We can do almost very little thing, especially for nowadays. This kind of research topics becomes very resource intensive. So I think that's also why we are all working on AI and cybersecurity. So you can also imagine this kind of grant or fund is more sufficient for this kind of area and the related topics. So I think it's also very important to timely maybe adjust your research direction a little bit based on the most maybe popular and trendy topics and techniques, so that you get a better chance to continue your research. Actually, even for myself, from the beginning of my research, I do this kind of runtime verification and a program analysis. I'm always looking into code. It's just nowadays, large language models are capable of writing code, understand the code, analyze code. So that's why I just try to look into what kind of role they are playing in this software world. So I think it's very important. And, so I think I will make this situation more challenging for people following me.
So research career. I've done quite a few different things. My bachelor's was a 4-year degree in computer engineering, not computer science, which is a little bit different. And the thing that I liked most during my undergrad was actually FPGAs, which is the thing that Wai Tan likes too. And so I got to this sort of, and the other thing I liked was robots. And so I got to the end of my undergrad, and I'd done some jobs for a web company, and I didn't like web at all, because JavaScript is literally the worst thing ever. So then I was like, I want to do more FPGA stuff, but in New Zealand, which is where I'm from, there's not very much FPGA stuff in general. So that was one of the reasons I went and ended up looking at higher research, was so that I could keep doing hardware stuff. And that was how I sort of ended up with my PhD supervisor. He was a hardware safety guy, so looking at timing analysis and proofs that various things would work the way that you want them to. And as it turned out, I didn't realize when I started my PhD, but I didn't actually like that topic very much. And this is something that is quite common in the higher degree journey. When you start your PhD, you might think you like a topic, and it's only after you've worked on it for 12 months or 18 months or 2 years that you actually go, you know what, I don't like this topic very much. It's full of stuff that's very uninteresting. So at the very end of my PhD, I realized that actually very close to safety is security, because for safety, you're relying on all of these assumptions. And one of the things I didn't like about the safety field was that all of these assumptions seemed very broad to me, like we trust that the computer will do what we want it to. And so that was when I started looking at the security side of things, and that was when I realized that I really, really liked security and downstream security of stuff. It also had less formal methods, which I appreciated a lot. So then I got into security, which was how I ended up in my postdoc in New York University at the Center for Cybersecurity there. And because I had the very strong background in hardware, I was able to get into hardware security quite quickly. And this was something that my postdoctoral advisor said was one of his strategies, is he really liked to hire postdocs that actually had experience outside of security and experience with other things. Just as I think Jingling mentioned a moment ago, when you know something else, you can actually just apply security to it. And so that's what my postdoctoral advisor liked to do. He would hire people that knew a lot about something, and then he would get them to add security to that thing. And so that was a really nice sort of strategy for him, but also it was very beneficial for me. So I was able to learn a lot of security stuff from him. And now I'm an academic at the University of New South Wales, and I'm able to broaden that even further. Now I'm picking up sort of new stuff in the education and teaching area. How do we best teach students some of these concepts too? In terms of advice that I would give if you're considering higher degree studies, if you're considering PhD, curiosity, which I heard mentioned earlier, is very important. Passion about what it is that you're working on. And I also think the relationship that you have with your supervisor is very, very important. You need to know that you're able to work with their supervision style. Everyone on this panel probably has a different supervision style. I can tell you that mine is very chaotic, which not everyone likes. But some students really, really like chaos, and so do I. So for me, that's kind of ideal, because we can go do chaotic, manic energy together. So yes, that's probably the three things that I would say are really important as you consider your own research careers, is to be curious, to be passionate about what it is you're doing, and to work with people who you are really able to work with super well and have a good connection with.
Yeah, so I think maybe I will provide some comments probably from a slightly different perspective, because I'm from China, but I did my PhD and my master's in Australia. So these are very two different cultures. So maybe I will talk a bit more about like this kind of cultural difference. So first, so I think if you want to do a PhD, the first thing you need to have is basically passion, right? You need to be passionate about your research topics. And also because like my PhD supervisor told me that basically doing a PhD is like taking a roller coaster, right? So maybe at the beginning you are very excited because I I got this PhD scholarship, I got accepted by this very great graduate school. Right? At the beginning, you are very excited. Then probably after one and a half year, then probably you are very down. Right? Why? Because probably you have submitted your first paper, then you most likely got rejected. Right? So probably you are very down. Right? Then what I want to say is probably don't be frustrated because only later in my PhD I also know that even my PhD supervisor's paper they got rejected quite frequently actually. So because even so don't be frustrated, don't feel frustrated if you got rejected. Just try again, try a different venue, or maybe try to basically revise and resubmit, right? Because as I mentioned, even your PhD supervisor's paper they are not 100% accepted at the first try, right? And the other thing I want to mention is more about the cultural difference, because when I started my PhD, I also work as a teaching assistant to teach some undergraduate and also like some master coursework. So one thing I noticed is that basically most of the students from Eastern countries like China, Korea, Japan, they are afraid of asking questions actually. This is not good for Western culture because, for example, if you are a PhD student, then if you don't, you are afraid of asking your supervisor's question because you may afraid that he or she thinks you are stupid, right? Then your supervisor don't know that you have a question, you are struggling. They cannot provide any help to you, right? So this one thing. And the other thing is, I think. Because for my research area, it is about bridging the gap between theoretical research and also between the practice, right? So I need to usually work with different researchers with different expertise, right? So I think collaboration is very important, and also you need to do networking, right? You also need to advertise yourself, right? Because nowadays, if you are only good at doing research by yourself, then it is not good, basically, in academia. Nowadays, you need to be able to do networking, you need to be able to advertise yourself. This will definitely open more collaboration and more opportunities to you, right? Because, for example, for organizing this event, because basically what happened is Professor Huang and Dr. Li contacted me for co-organizing this event because we had a paper previously about some GPU implications of post-quantum cryptography. And then basically after I received the email from Professor Huang, then I contacted Dr. Gajian Xue. Then he basically took charge of this of organizing this event. So now basically we have all the fantastic speakers here and we have a very successful event. So you can see this is like the power of collaboration and networking. Right? So I think this is what I want to say.
Okay. I'm the last one. We have plenty of time. Okay. I think it's quite okay. I think it's quite a big question about research area. It's we're starting from PhD or peer PhD and after PhD and faculty. It's a very long range. I might start from first introduce my trajectory for my research. In my bachelor is different from computer science. I'm a bachelor of mathematics, and when I was doing my bachelor and I realized that okay, there are so many math talents in the school. So and at the meantime, I have some interest in the computers actually at that time. So I know someone doing some like at that time it's evolution algorithms, try to optimize something. It looks cool, so I start my the journey related to computer science. And then when I take master for statistics, but I'm still doing a lot of things regarding the evolution algorithms. But it's more about the application. It's like we apply some algorithm to solve some real problems. Okay, you can say there's no real tech novelty. At that time. After I did like a lot of work regarding applications, I realized that maybe perhaps I can do better. I can really develop something from a technical part is have some technical knowledge to develop some new algorithm to do that, to solve more problems. And then I start my journey about the computer science, and doing my PhD, I realized that, okay, I can. So doing my PhD at the very beginning, I'm still, although I'm doing some like the technical things about develop some algorithms and just evaluate this algorithm compared with others, but still like not the mainstream one, because I'm not quite sure if I can do the mainstream one. But I'm quite sure it's like, okay, I can do some specific one. I can do it good. I can do it well and better than a lot of people. So I start, okay, perhaps I can do more. So I started my journey about machine learning. It's more like the pure algorithm design and focus on more mainstream algorithms. And I'm doing it until now. So I think for my research trajectory, it's like I'm building my confidence in the unknown areas. So I think the students, if you are not the such talent, you can start building your confidence step by step. Okay, step by step. It's for someone, perhaps you're lucky, like you can just reach the level, like you can perform very well. But for someone, perhaps you just reach a level like you can easily to manage to be the best. In that case, you can consider to do more. Yeah, it's like you build your confidence step by step, and finally find some place you feel comfortable. So what comfortable I mean? It means that you find that it's still challenging to you, but you can manage to be, to do something good. Okay, do something impactful. Yeah, that's kind of level I think is comfortable. Yeah, so it's a research, comfortable to research. Okay, because it's still challenging to you. Okay, and you can do something. Yeah, good and to the field, develop this area. So that's a position, good position for every researcher, I think. Yeah, so that's my trajectory. It's like I think most important thing you can build up your confidence step by step. And another thing is about the PhD study. So the first lesson from me to my students is like I will ask them if AI this area died, okay, what's the meaning to do this PhD? Yeah, like what Jason's supervisor told him at the very beginning. Okay, this area is dead. Okay, yeah. So what's the meaning to do the PhD, AI PhD study, right? So I will ask them this question, and the answer is actually simple. It's like, so the PhD study is not. Of course, I will not say outcome is not important, but the more important thing is the process you get your PhD degree. And what's the most important thing to get your PhD degree? I think two things. The first thing is critical thinking. It's similar to curiosity. Okay, it's like, but it's a more technical one. It's like critical thinking. And the second factor is your knowledge. Okay. So you need to learn some knowledge, basic knowledge. For example, some basic statistics, basic mathematics, okay, basic theorems from computer science, okay, yeah, from information theory. That's something. Yeah, it's your knowledge base. You need to make you learn a lot of knowledge. And second, and before that is critical thinking. What is critical thinking? It's like you can consider critical thinking is like you just say someone or say something, okay, it is not true, okay. You can just say it's not good, and give some very critical point to some event, okay. But it is not the critical thinking. Critical thinking, it means that if you really want to challenge something, you need to challenge it at first and providing evidence, okay. As long as you have evidence and you can challenge things, okay. That is how we do research. If you really want to do research, the most important thing is to challenge. And after you challenge with evidence, you can get a real motivation and you get research questions. When you have a question, the next thing is easy, just manage to solve it. Okay. If you have enough knowledge, you can solve it. If you do not have enough knowledge, you can find someone, collaborate with you, and solve it. Okay. Yeah, that's the most important thing, I think, for the PhD study. In PhD study, the outcome is important. Papers are important. But the most important thing you need to realize that after PhD, you actually can be capable to solve a lot of things, not just the problem in your own area, because you have your mind, critical thinking in your mind. Okay, when you meet the new problem, you can always find, okay, what is the biggest issue for this frontier research, and with evidence, and challenge this one. Okay, challenge this issue with evidence, and then just find people or by yourself to solve it. Okay, so you always can do the best research when you have when you have critical thinking in your mind. Okay, that's the most important thing for PhD study. Especially, I think it's important to let students understand that, because currently, for this AI area, I think perhaps after 5 years, ChatGPT can do 90% work of human beings. Okay, so it will cause a lot of anxious for PhD students. I can feel that. It's like always they can feel, okay, especially for AI area, we have many papers accepted by the top conferences. Okay, if we plus machine learning and computer vision and NLP, it means that we have 9 top conferences in the AI area, and I don't know how many papers we accept. Maybe 20,000 per year. Yeah, 20,000 per year. Yeah, so everyone has a lot of papers. Perhaps it's good. Okay. And the students will feel very nervous about that. And now we also need to face the big challenge from company. Because company just, annotate data, train the model. That's simple. And they have money and annotate data, train the model. Okay. If they annotate a lot of data and train a very good model, it will replace a lot of things, a lot of researchers. One well-known example is like, one paper they aim to correct typo, and when they want to use vision language models before ChatGPT. Okay, but after ChatGPT, it's a very easy engineering solution. Just ask large language model to correct typos. Okay, so this kind of work is literally died. Yeah, so it's very hard to say if you got something new. It's managed to be more impactful than the ChatGPT in this kind of thing. Yeah, so it happens every day in current AI development. So, yeah, but I want to say is like some of students here might be a PhD student, but the most important thing, like you need to realize that you are really improved, okay, in terms of critical thinking and your knowledge, okay, your basic knowledge. Yeah, with critical thinking and basic knowledge, what you need to do is just okay, now we can step to the next one is how to find the faculty phase. Okay, yeah. So for the faculty phase, the most important thing is like, make yourself more stronger and make your profile better. Yeah, and how to do that is just the papers, grounds, and all of them need is like critical thinking and knowledge. Okay, and what you need to do next, just wait for the next train. Okay. As long as you have this kind of meta-knowledge, meta-skill in your mind, you can always wait for next train and do the good research. Yeah, that's what I want to share.
Okay, now it's time for the your abstraction.
Okay, I'm going to do the summary. Okay, first of all, you need to be curious. You need to have curiosity, interest, satisfaction, and then go deep into the topic.
자, 우리가 이제 이분들을 경험을 듣고 있어요. 경험을 듣고 있는데 왜 이분들을 여기까지 그 멀리 유럽에서 여기까지 모셔가지고 경험을 들을까라고 생각할 수가 있어요. 그런데 우리가 지난 3일간에 걸쳐서 인천 쉐라톤 호텔에서 이분들을 모시고 2박 3일간 기술 교류회를 했습니다. 근데 그 기술 교류회는 10분 말고도 우리 국내에 탑 티어 교수님들, 학자들이 오셨어요. 근데 탑티어 교수님들, 학자분들이 이구동성으로 하신 그 말씀이 뭐냐, 어떻게 이렇게 세계적인 분들을 모셨나 이거예요. 대만족을 했습니다. 그래서 무슨 말이냐, 여러분들은 이분들이 그냥 그렇게 보이죠. 젊으니까 머리가 세계적인 석학이라 해서 머리가 하얄 줄 알았는데, 여러분보다 여러분 형님 오빠 되는 정도밖에 안 돼요. 굉장히 젊죠. 근데 세계적인 석학입니다. 예, 세계적인 석학이에요. 여러분들은 어디서 이런 분들을 직접 볼 수가 없어. 그래서 그분들이 하는 이 개인 경험이지만 이게 굉장히 큰 의미가 있다고 저는 봐요. 그래서 그거를 이제 하나하나씩 여러분한테 풀어드리도록 하겠습니다. 이제 이분들이 이구동성으로 말씀하신 것이 호기심이에요. 호기심을 유지하시오. 또 이런 것들이 사실은 모티베이션, 어떤 일을 하시든지 모티베이션이 아주 중요하지 않습니까? 그래서 여러분이 하고 계신 일에 여러분이 정말 호기심을 갖고 있는지 다시 한번 돌아보시고, 그 다음에 연구라는 거, 공부라는 게 생각보다 길어요. 아무리 AI가 빠른 속도로 발전하고 있지만 여러분이 결과 내기는 적어도 6개월, 1년. 그래서 버틸려면 여러분이 그래도 호기심도 중요하지만 또 satisfaction, 만족도 해야 돼요. 여러분이 뭔가 만족을 해야 되고, 그 다음에 여러분들이 논문을 쓰시면 아시겠지만, 논문하고 프로젝트하고 다른 건 여러 가지가 있지만, 그 프로젝트하고 다른 것 중에 하나가 저는 좀 깊이라고 봐요. 여러분 깊이 들어가야 돼요. 그죠? 사실 인터넷에 AI에 대한 지식 차고 넘칩니다. 근데 그게 논문이 될 수가 없어요. 이게 논문이 되려면 go deep, 한 단계 더 내려가야 됩니다. 그걸 말씀을 하셨고요. 그 다음에 아주 또 중요한 말씀을 하셨어요. Hard work pays off. 여러분이 아무리 뛰어나다 하더라도 노력을 해야 됩니다. 노력을 따라갈 수가 없어요. 그래서 여러분이 진정으로 노력하시고 고생하시면, 그리고 제대로 그걸 하신다면 페이오프, 보상이 따른다는 겁니다. 그래서 노력도 중요성도 말씀을 하셨습니다.
Okay, the second important point is we try to think from different perspective, and this is very important. Maybe AI guy can solve the computer vision problem. Computer vision guy can solve the electronic engineer's problem. So we try to work in a different group. Before that, you have to go deep. You have some knowledge strong in one area. Like Ahmed, professor want to hire someone who has knowledge in one area. But other than that, you also need to broaden. When you have something deep enough, some knowledge on one area, try to look from different angles.
그 다음에 이제 아까 go deep 한 단계 내려가라고 했잖아요. 근데 이제 좀 그거하고 좀 이제 어떻게 보면 상충될 수도 있는데 또 다양한 시각에서 보라 했거든요. 근데 이게 사실은 얼핏 보면 상충되는 것 같지만 그렇지 않습니다. 여기 보시면 아시겠지만 전자공학 하신 분들이 AI 하시고 또 수학 하신 분들, 통계학 하신 분이 또 AI 하시고 어떻게 그게 가능하지? 서로 다른 어떤 그런 백그라운드 갖는 분이 단지 컴퓨터 사이언스만 아닌데도 불구하고 AI를 하시고 더 잘하신단 말이죠. 그건 뭘 얘기하냐면 굉장히 다른 시각에서 어떤 문제를 보고 접근하는 게 중요하다. 그런 말씀을 하셨고, 그렇게 다른 시각에서 뭔가 보고 접근하려면 그죠? 자기만의 그 백그라운드에서 깊이가 있어야 된다는 거죠. 그래서 우리 아까 하드웨어 하신 하몬드라는 영국은 아니죠. 뉴질랜드에서 오신 분 말씀이 자기는 하드웨어 아주 스트롱 백그라운드를 갖고 있다 했어요. 아주 젊었을 때부터 아주 하드웨어 좋아하고 그래서 FPGA 로봇 좋아하고 이렇게 했었는데 어느 순간에 여기에다가 시큐리티를 적용하면 어떨까 해가지고 PhD는 그런 자신의 스트롱 백그라운드인 하드웨어로부터 출발해가지고 거기다 시큐리티를 적용했다는 거죠. 여러분 생각할 때 하드웨어 어떻게 시큐리티가 필요하지라고 생각할 수 있는데요. 시큐리티는 모든 곳에 적용이 됩니다. 모든 곳에. 그래서 그런 말씀하셨고 특히 그 하드웨어 백그라운드 가지신 분이 어떤 걸 또 강조하셨냐면 슈퍼바이저하고 릴레이션십이 굉장히 중요하다 했어요. 그래서 여러분들이 석사, 박사인데 슈퍼바이저하고 뭔가 관계가 안 좋다면 여러분 한번 돌아보실 필요가 있어요. 물론 슈퍼바이저한테 문제가 있을 수도 있지만 반대로 여러분한테 문제 있을 수 있어요. 슈퍼바이저는 많은 경험이 있습니다. 많은 학생들 지도했어요. 경험이 많습니다. 근데 여러분이 슈퍼바이저 정말로 정말 긴밀하게 도움을 받아야 될 슈퍼바이저하고 그 릴레이션십 좋지 않다면 그것은 여러분의 리서치에도 상당한 영향을 미칠 수가 있다는 거. 그다음에 아까 그 스트롱 백그라운드, 우리 하드웨어 스트롱 백그라운드 갖고 있는데 그분이 그런 말씀을 하셨어요. 뭔가 something에 뭔가 홀려야 된다는 거죠. 그죠? 내가 그냥 단순히 좋아하는 게 아니라 뭔가 한 분야에 미칠 정도로 그러면 좋겠다라는 것입니다. 이건 뭐 보안 얘기만 하는 건 아니에요. 여러분이 분명히 좋아하는 그런 부분이 있을 건데 그 부분을 여러분 어떤 그죠? 연구로 잘 연결시키면 좋은 성과, 즉 남들이 보지 않는 어떤 새로운 시각에서 다른 시각에서 좋은 어떤 성과가 있지 않겠는가 그런 말씀을 하신 것 같습니다.
Okay. Point number 4, I think Professor already said before I summarize. Actually, close relationship with professor or your senior member, very important. And learn from this senior. And then you can also learn from many talks like this, seminars, try to attend because you spend 1 hour of time, understand something state of the art, better than you spend 10 hours reading the papers. You will not be able to understand. So 1 hour is saving you a lot of time. Okay.
Just a moment. 네, 한 가지 빼먹었네. 우리 여러분 슈퍼바이저에는 지도 교수만 있는 게 아닙니다. 여러분 착각하시는 것 중에 하나가 슈퍼바이저 하면 우리 지도 교수님만 생각하는데 그거는 정말 제가 안 좋은 표현 하수입니다. 사실은요, 이 연구 세계도 이렇게 하이라키가 있어요. 연구실에 가보면 여러분이 학부생이다. 그러면 여러분 지도교수보다는 바로 위에 있는 그 고년차 학부생 또는 석사과정 학생이 여러분한테 더 도움이 될 수가 있어요. 석사과정 학생이 여러분 도와주면서 석사과정 학생이 뭐 본인 어떤 힘으로 해결할 수 없는 문제가 있다. 그러면 또 상위에 있는 박사과정한테 또 물어봅니다. 상위의 박사과정이 또 해결하지 못하면 또 상위에 있는 또 교수님한테 물어보고. 이건 뭘 얘기하냐면 시니어가 여러분 선배가 굉장히 중요하다는 거예요. 굉장히 중요합니다. 그런데 많은 학생들이 그걸 인식을 못해요. 인식을 못하고요. 오로지 지도 교수님만 바라봐요. 그건 정말 잘못된 겁니다. 그래서 여러분 시니어 멤버들이 훨씬 더 여러분한테 직접적인 도움을 줄 수 있는 많은 경험들을 갖고 있다. 그렇기 때문에 여러분 시니어 멤버들을 하늘같이 모셔야 됩니다. 왜냐하면 여러분한테 직접적인 도움을 줄 수 있으니까. 예.
Okay, so number 5 is money is very important. This doesn't mean that you have to find money. It means that you try to adapt your research area to something trendy because this will help the professor to get more funding for you. So it is a very realistic problem and we cannot avoid that. So sometimes our interest, we have to do some sidetrack. But as long as you can maintain your interest and you do some sidetracking so you can get the funding, it's a win-win situation.
Just pass. Keep going.
Okay. So another one is that do not afraid of asking questions because I have the same feeling like the panel saying. I have some experience teaching to some Germany students. They will not let me go. After the class, they will ask until last minute. So, but in the Eastern country, like I'm from Malaysia, it's the same. When I say any questions, some of them taking the bag, going to leave. So it's very different. So if you don't ask questions, mean you do not understand or you are not interested to understand. So this is very bad. I hope that we can change this culture.
질문이 얼마나 중요한지 아시죠? 근데 이제 사실 그렇잖아요. 우리나라 보면 그 분위기가 그렇잖아요. 질문하면 괜히 그죠? 눈총 받는 것 같고. 사실 제가 또 교수지만 다른 세미나 가서 또 제가 또 질문자의 입장이 되면 청중의 입장이 되면 똑같아요. 여러분과 똑같습니다. 똑같이 이해를 돼요. 그런데 그렇게 되면 그걸로 끝이에요. 더 이상 발전이 없습니다. 사실은 이런 세미나나 이런 데 왔을 때는 적어도 하나씩 질문하셔야 됩니다. 그러면 적어도 그거 한 가지는 여러분이 얻어가요. 그런데요, 여기서 이런 다양한 지식들은 사실은 여러분 것이 아니에요. 그냥 지나면 다 잊어버립니다. 그런데 여러분이 질문했던 것은 잊어먹을 수가 없어. 여러분 지식이 됩니다. 그런데 여러분이 그렇게 생각할 수 있어요. 나는 잘 모르는데 내가 질문하면 창피한 거 아니야? 모르기 때문에 여기 와 있는 거죠. 모르기 때문에 와 있는 겁니다. 그래서 이분들이 어떤 자신의 분야에서는 깊이 알지만 또 조금만 분야 벗어나면 몰라요. 그래서 아무튼 질문의 중요성 말씀해 주셨습니다.
Okay, the last one is build your confidence step by step. You may have a very high aim, but start from the low and do not get frustrated. Like Raymond paper rejected is very normal. So rejected, try, reject, try. But build your confidence slowly and reach the top. This is the what they want to give to you.
제가 이제 이거를 하면서 성공담뿐만 아니라 실패담도 공유했으면 좋겠다 얘기를 했습니다. 근데 아까 제가 말씀드렸죠. 이분들은 세계 탑 티어 사이언티스트들입니다. 그래서 이 사람들이 내면 100% 다 될 것 같지만 똑같다는 거죠. 이분들도 여기까지 올라오기 위해서 수많은 실패를 경험했습니다. 그래서 build confidence step by step. 그렇죠. 하루아침에 될 수 없습니다. 여러분도 지금 실패를 겪고 있으면 제대로 하고 계시는 거고, 실패도 겪지 않고 있다. 그럼 뭔가 문제가 있는 거죠. 그래서 그렇지만 그 실패를 실패했다고 해서 리젝트했다 해서 그걸 굉장히 힘들어하고 그러면 안 됩니다. feel comfortable. 그래도 편안한 걸 유지를 해야 돼요. 어느 정도 만족하셔야 돼요. 나는 여전히 도전하고 있고 그러면서 뭔가 할 수 있는 그런 단계적인 그런 게 필요하지 않나라는 생각을 해요. 그래서 저희도 마찬가지예요. 저희 교수도 마찬가지입니다. 저희 교수도 여러분 눈에 볼 때는 겉으로 봤을 때는 우아한 백조지만 내부적으로 여기저기 깨져요. 프로젝트 내고 가서 깨지고 리젝되고 논문 같은 게 하루에 몇 개 리젝되는 경우도 있고 정신없습니다. 근데 take it normal. 자연스럽게 받아들여요. 내가 뭔가 문제 있구나. 내가 아직 보완해야 될 부분이 있구나. 그렇게 생각하시면 여러분들이 제대로 하시는 겁니다. 그렇지 않고 그냥 frustrated, 좌절하면 그걸 끝나요. 그래서 여러분들이 리젝 받고 이런 것들은 굉장히 좋은 과정입니다. 여러분이 성장하는 과정이. 그걸 아까 confidence step by step 이렇게 표현을 한 것 같아요. 너무너무 좋은 것 같아요. 그 다음에 이제 우리 와이콩리 박사가 이제 언급하지 않았던 거, 소소한 것들 제가 얘기하겠습니다. 영어가 아주 중요하다. 여러분, 퓨처 커리어에 있어서 영어가 중요하다 했어요. 그래서 여러분들이 한국에 있을 수도 있지만, 이제 여러분 세대는 세계적인 세계화 시대예요. 그래서 분명히 애국 가서도 일하실 것입니다. 그래서 영어가 아주 커뮤니케이션 중요하다는 거. 그 다음에 또 어떤 분이 얘기했어요. 보안은 이머징 에어리에서 아주 좋은 기회를 제공한다. 그렇습니다. 지금 AI가 이머징 에어리예요. LLM이 뜨고 있습니다. LLM이 뜨면서 또 LLM의 시큐리티가 뜨고 있습니다. 그래서 그런 좋은 말씀을 하셨고요. 또 어떤 분은 그런 얘기를 했어요. 컨퍼런스 가가지고 많은 그런 스피커들을 만나고 인사하라고 하는 거죠. 그리고 나중에 그런 사람들을 또 만나게 되면 그분들이 여러분 커리어에 굉장히 큰 도움이 될 것이다. 그런 얘기를 했고요. 또 어떤 분은 그런 말씀을 하셨어요. 여러분의 에어리어, 여러분의 어떤 분야를 뭔가 트렌드가 있고 뭔가 파퓰러 그런 현재 그 트렌드, 그런 많은 사람들이 관심 있는 그런 분야에 맞추라는 말씀하셨습니다. 이게 맞는 말 같아요. 여러분이 아무리 수학에서 아무리 어떤 분야에서 깊이 판다 하더라도 오디언스가 누굽니까? 아까 제가 오디언스에 여러분 포커스를 해야 된다 했어요. 여러분 논문을 읽는 그죠? 그런 사이언티스트들, 또 여러분 논문을 리뷰하는 리뷰어들, 이게 여러분 청중이란 말이죠. 근데 청중이 말이죠. 여러분의 페이퍼, 여러분의 그 프로덕트에 관심이 없으면 좋은 코멘트를 줄 수가 없습니다. 근데 이건 당연한 거 아닙니까? 할 수 있는데 그렇지 않습니다. 우리 연구자들 보면 자기 어떤 분야에 갇히는 경우가 많아요. 지금 흐름은 이렇게 가고 있는데 갇힙니다. 예를 들어서 5년 전에 AI 아무도 안 했어요. 7년 전에 아무도 안 했습니다. 근데 지금은 어때요? AI를 안 하면 자신의 분야에서 살아남기 어려워요. 무슨 말이냐? 예, 그 트렌드에 맞춰야 된다는 겁니다. 여러분이 어떤 분야를 하시든지 그 트렌드에 맞춰야 된다. 그렇지만 이것은 말은 쉽지만 쉽지 않다는 거죠. 그렇지만 중요하다는 겁니다. 그 다음에 굉장히 좋은 말씀들 많이 하셔서 제가 좀 더 하겠습니다. 그 다음에 또 우리 마지막 그 박사님이 그런 말씀 하셨어요. PhD를 하는데 공부하는 데서 중요한 거 크게 두 가지가 있다. 하나, critical thinking. 그죠? 뭔가 문제를 찾고 도전하고 또 거기에 대해서 어떤 증거, 이런 것들을 이렇게 찾고 제공하고 이런 critical thinking이 중요하다 했습니다. 그래서 사실은 지금 이제 시대가 완전히 바뀌었어요. 이제는 뭐 여러분이 교수로부터 어떤 많은 지식을 배우기보다도 이제 챗GPT로부터 더 많은, 그죠? 그 인터랙션을 하고 배우는 그런 시대가 됐습니다. 그래서 근데 이제 챗GPT든지 뭐든지 사실은 제일 중요한 게 크리티컬 띵킹 같아요. 그죠? 챗GPT가 여러분을 속이고 있잖아요. 근데 속이는지 안 하는지를 어떻게 알아요? 그죠? 크리티컬 띵킹입니다. 여러분이 비판적으로 생각하면 챗GPT의 오류를 찾아낼 수가 있어요. 아무튼 이 크리티컬 띵킹이 중요하다는 걸 말씀하셨고, 그거에 못지않게 베이직 날리지, 아까도 나왔는데 이 기본적인 지식이 중요하다는 거죠. 여러분 수학, 통계, 컴퓨터 사이언스에서 배우는 그런 기본적인 거 화려하지 않습니다. 이거 교과목 필수니까 듣고는 있지만 이거 왜 배워야 되는지 모르죠. 교수도 얘기 안 하고. 그렇지만 오늘 얘기하는 거죠. 오늘 얘기하고 있습니다. 여러분 맨 끝에 있는 그 교수님이 AI 쪽에 아주 탑 컨퍼런스에 엄청난 논문을 냈어요. 근데 그분의 그 백그라운드, 그 베이직 날리지가 통계입니다. 통계. 우리는 무시해요. 통계 어디다 써먹어. 근데 통계를 저런, 그죠? 최신 AI 분야에 적용을 하고 있어요. 그죠? 어떻게 그렇게 가능하지? 라고 생각할 수가 있는데, 아무튼, 여러분들은 아무튼 이해 안 가셨다 하더라도, 아무튼 여러분이 배우는 1, 2학년 때 초급 그런, 기초 과목들이 너무너무 중요하다. 여러분 롱런한 데서 굉장히 중요하다라는 말씀을 강조를 하셨습니다. 일단 뭐 제가 알아들은 거 이 정도, 이 정도입니다. That's it for me. So we end this session presentation of research career, and time is 12:47. And we are supposed to end this talk at 1 p.m. So we have some time for Q&A. Okay, so it's time for Q&A. So 먼저 이걸 하기 전에 제가 여러분한테 진짜 감사를 드립니다. 저는 아무도 안 올 줄 알았어. 그런데 많은 분이 오셔가지고 물론 뭐 누구의 어떤 고은이라든지 또 프레셔에 의해서 올 수도 있겠지만 여러분은 선택 잘하신 겁니다. 한 사람도 조는 사람이 없어. 아무튼 잘하신 거고, 저 우리 이 행사 주최자를 대표해서 너무 감사하다 말씀을 드리고 싶습니다. 자, 어떤 질문도 좋습니다. 여러분도 영어 하실 수 있는 분은 영어로 하시고 또 한국말이 편하면 한국말로 하시면 되겠습니다.
First of all, thank you for having your valuable time here today. And as a member of COFS, thank you for having your meaningful moment. The talk concert was very informative, and I would like to ask some questions. First of all, as a computer scientist, I want to ask all of you which one is better, being the generalist or specialist? Because I have 15 years of the experience on the educational industry, and also now I'm working for some kind of science stuff. But after I majored just linguistics and education, I think being a generalist is better than the specialist. But in terms of the AI stuff, I think nowadays being a specialist looks more fascinated to the industry. So I would like to ask you, which one do you think is better, being the generalist or specialist? Thank you.
So thank you for the question. I think being a researcher, you need a broad spectrum of your capability. So basically, which means that you need to be a generalist of the entire computer science or computer security, cybersecurity area, but you have to specialize, especially, for example, in AI security. So you are a specialist, but you are a generalist in the entire cybersecurity area because you have to understand all these kind of attacks and defenses technologies and cryptography in general, and then bring these domain knowledge into AI security. Because AI security is not only a theoretical problem, but also you need a domain knowledge, right? So most of the time you're a generalist, but you have to specialist in a specific area or in a specific domain area. Yeah. And this is my simple answer.
예를 들어서 컴퓨터 사이언스를 예를 들면 그 컴퓨터 사이언스의 다양한 분야를 알 필요가 있고, 그 다음에 그 중에서도 어떤 특정한 분야에서는 스페셜리스트에 준하는 정도의 어떤 또 도메인 지식이 필요하다. 그러니까 뭐 어떤 한쪽만 강조한 것 같지는 않아요. 그렇지만 아무튼 우리 연구자들은 주로 이제 스페셜리스트지 않습니까? 어떤 한 자기 분야만 알고 좀만 벗어나면 몰라요. 그런데 우리 제이슨이 강조한 것은 그래도 제너럴리스트 측면을 또 중요하다 이런 것을 강조한 것 같습니다.
Yeah, I want to add something on Jason's comment. I think that the question is from a very experienced educator, but the audience are mainly early career students. So I think the answer to you and to them could be different. So actually, as an educator, I myself, I always encourage students be specialist first, because specialist is very, very, very difficult to do. In your lifetime, you only have the 3 to 4 years of PhD to be a specialist. After you're out of there, you are dragged by many things: your family, your spouse, your any personal life, and also your career. You will not have the chance to be a specialist anymore. So these 3 to 4 years is very special. Be a specialist. Try to not to attracted by many things. A few things that is enough that you can handle. So after that, it's like a tree. Your tree, if your root is strong enough, you grow up, you will be very blossom a lot. If your root is not strong, sorry, you will collapse. That is my advice. But for you, of course, generalist is better.
그러니까 우리 말씀하셨어요. 그러니까 질문자 또 관심자의 어떤 시각에 따라서 상황에 따라서 좀 다를 수가 있는데, 어차피 우리는 사실은 연구자거든요. 그래서 우리 닥터 와이콩 리 박사는 진정한 스페셜리스트 되는 게 사실 어렵다는 걸 강조한 겁니다. 우리가 스페셜리스트라고 하지만 많은 사람이 자신의 분야에 그냥 갇힌 자신의 분야라는 그런 우물에 갇힌 그런 경우가 많아요. 근데 그게 진정한 스페셜리스트는 아니죠. 그래서 진정한 스페셜리스트가 되기 위해서는 적어도 3, 4년의 그런 과정이 PhD 과정과 같은 그런 과정이 필요하다. 그리고 그런 진정한 스페셜리스트가 되고 나서 이제 우리가 그 굳건한 뿌리를 바탕으로 해서 우리가 다양한 분야에 우리가 또 우리가 그 영향을 미칠 수 있다라는 것 같아요. 사실 그게 현실적인 것 같아요. 우리가 연구를 할 때 처음부터 다 제대로 알 수가 없어요. 뭔가 시큐리티면 시큐리티, 뭔가 하드면 하드웨어, AI 뭐 이렇게 출발하지 않습니까? 그렇지만 결론은 뭐냐? 그 특정한 분야에 머무르면 그걸로 끝난다는 거죠. 그거를 하나의 뿌리로 하되 계속 가지쳐서 저널리스트처럼 다양한 분야로 우리가 확장할 수 있어야 된다. 저는 그렇게 개인적으로 생각합니다. 예.
First of all, thank you for everyone's speech, and I want to ask that the data is very important during AI or security experiments, but during experiments there are cases where you feel the quality or quantity of data is insufficient. So I would like to ask how you respond to these situations. Thank you.
Okay. Yeah, I think currently definitely the quality is most important. Yeah, because you cannot stand out from the 2,000 papers per year. Yeah, just with 2 papers, right? Yeah, so quality is always important. Yeah, so you need to consider some impactful problem and try to solve it. Yeah, with novel solutions. Yeah. Yeah, quality is always important. Yeah, try to do something impactful. Yeah, it's very important. Yeah. Data quality. Oh, sorry. Oh, sorry. That's my bad. Okay, yeah. Sorry. That's my bad. Yeah. So data quality and data quality. Yes. How to say data? I think the success of ChatGPT actually means that data quality is important. Yeah, because they try to annotate data with a selected group of people. Yeah, instead of just try to annotate data. Yeah, so data quality is very important currently. Yeah, and there's a topic called data set distillation. Yeah, it's very popular. Yeah.
Okay, let me speak in Korean. Okay, 이제 질문은 처음에 AI에서 데이터 퀄리티하고 퀀티티 중 어느 게 더 중요하냐 이렇게 했는데 이제 우리 AI 대학께서는 그래도 퀄리티가 중요하다 이렇게 말씀하신 것 같아요. 혹시 더 자세한 것은 끝나고 한번 질문하시면 좋을 것 같고 그 다음에 이제 그 전에 이제 답변하시면서 퀄리티가 임팩트풀하다 더 중요하다 이렇게 한 것 같아요. 아마 논문 말씀하신 것 같아요. 연구에서. 그래서 이제 제가 그거에 대해서 말씀드리고 싶은 것은 이제 우리가 졸업해야 되잖아요. SC의 논문도 있어야 되고 또 프로젝트에서는 또 그 한두 편도 아니고 많은 수의 또 실적을 요구하잖아요. 그게 우리 현실입니다. 현실은 현실인데 여러분의 커리어 입장에서는 사실은 그게 그렇게 썩 바람직하냐 모르겠습니다. 근데 임팩트는 별로 없어요. 이제 임팩트가 없습니다. 우리 시대가 이제 선진국에 진입했기 때문에 그런 단순한 그런 퀀티티는 별로 의미가 없습니다. 10개의 그냥 그런 논문보다도 하나의 그런 제대로 된 논문이 더 임팩트가 높습니다. 그래서 퀄리티 페이퍼 포커싱 하시면 좋을 것 같고 그럼 퀄리티 페이퍼를 위해서는 여러분이 어떻게 해야 되냐 처음부터 그 하나만을 만들기 위해서 디자인하고 그렇게 해야 될 것이냐 그렇지는 않습니다. 어떻게 보면 아이러니컬할지도 모르지만 여러분이 많은 페이퍼를 쓰고 그걸 많은 페이퍼를 제출하고 많은 페이퍼에 대해서 그 리뷰로부터 호평을 들으면서 여러분의 그 퀄리티 페이퍼가 나옵니다. 그래서 아까 누가 얘기했었죠. 하드워크 페이스 오프. 방법은 없습니다. 여러분이 많은 논문을 제대로 된 과정을 통해서 쓰려고 할 때 퀄리티 페이퍼가 나오지 않나 이런 생각이 듭니다. Next question, please.
Hi everyone. Thank you so much for your sharing your experience. My name is Abdurrahman and I am from Pakistan and I am doing my masters here. From your experience, it is very fruitful for me as a young researcher, how I should see my career as a young researcher. My expertise recently lies on AI and computer vision, but I have no expertise on security. I have started to study about the generative AI, and I have questions regarding large language model, specifically to the code intelligence. Like, if we talk about the software side, the code intelligence is good, like the coding in Python and C++ is good. But when we specify this thing to the hardware, then the challenge comes. Like every hardware have different style of code and debugging. So if we use generic model for some hardware, it might lag. But to be specific with some hardware, if we want to fine-tune our model, so what are the steps required to train any LLM to specific hardware?
Are you talking about designing hardware or running it on hardware?
Like coding existing hardware.
Okay.
There's some like syntax, there's some documentation, but coding intelligence don't know about this. So how we can fight you?
Yeah, so you're absolutely right in that most language models that are available are much, much better at writing software than they are at writing hardware code. This is due to a number of reasons. The most massive one is just the difference in the amount of training data that's available. The previous question on training data impacts this as well. If you look at Python code online or C++ code, millions of repositories, really high quality open source stuff. You know, Python's got really high quality frameworks, never mind the AI frameworks like PyTorch and stuff, but you've got web frameworks like Flask and you've got security frameworks like CodeQL and whatever. So tons and tons of open source good quality stuff, and C and C++ is the same. Like all of Linux is open source, GCC is open source, what have you. Hardware, it's a different story. There is very little open source hardware, and what is available is usually stuff that's been written by hobbyists and students, which means it has a much reduced quality compared to industry hardware, right? So Intel does not open source the VHDL or Verilog that specifies their CPU, or NVIDIA does not open source the RTL designs for their GPUs, anything like that. So we do have a big problem when it comes to, okay, we want AI to make those designs. How do we do that? We can train over what is available. We've done that in our group. So we've produced some language models that can do some sort of training. And we do the same thing that GitHub Copilot does. So we scrape the internet for open source. We put it into a pipeline. We fine-tune a code language model over it. But that still has performance limits because it's still not capable of doing the really high-quality, high-impactful design. So this is a question that is still trying to be answered. What you have just asked is actually an open question in the literature. There are academics like myself and engineers at the big companies like Intel and NVIDIA and Synopsys, and I know because I have talked to them, that they don't know how to solve this problem either. Certainly they have the ability to train their own language models over their own data, but then it's all proprietary. Nobody knows how well they work. Even they don't really know how well they work, because then they haven't got the big open source benchmarks that software has either, like human eval. So yeah, this is an open question. There's really no good answer other than, you can do all of the typical tricks that we know from software, like retrieval augmented generation or in-context learning, or any of these things that you can do to improve software code, we can do to improve hardware code, but it's a struggle. And the performance is still much lower than in the software space.
Let's publish a paper together. I summarize the answer. It's basically software. It's easy to prompt the ChatGPT or some LLM to get the answer because you have a lot of GitHub available. But hardware is really difficult. It's hard to find the open source. Due to this reason, hardware is an open problem that how you query the LLM and get the real hardware design correctly. Even if not really the hardware, the microcontroller code also, assembly code also difficult. So this is an open problem. That's why Harman is working in this area as well.
알아들으셨죠? 뭐 소프트웨어는 여러분이 잘 아시겠지만 진짜 엄청나게 많은 오픈 소스들이 있지만 하드웨어 같은 경우는 반대로 그 오픈 소스 찾기가 어렵다네요. 그래서 이런 LLM 시대이기는 하지만 그런 하드웨어 오픈 소스가 없기 때문에 그 LLM을 활용하는 게 연구에서도 어려움이 있는 것 같아요. 그런 차이점이 있다. 자, 지금 시간이 됐습니다만 하나만 딱 받고 싶어요. 누구한테 받고 싶냐면 우리 언더그레이드 스튜던트 학부생한테 질문 받고 끝내도록 하죠. 우리 학부생 중에 한 사람이 대표로. 오케이.
안녕하세요. 가천대학교에 이번에 입학하게 된 이수아라고 합니다. 이번에 토크 콘서트 정말 잘 들었는데요. 제가 정말 궁금한 것은 이제 이 분야에 대해서 공부를 시작하는 입장에서 어떠한 마음가짐으로 이 분야에 대해서 접근을 해야 하는지에 대해서 조언을 듣고 싶습니다.
이 분야라는 게 어떤 분야? 예를 들면
인공지능이나 컴퓨터 사이언스, 데이터 사이언스 쪽에 대해서 어떠한 방향성과 마음가짐을 가지고 접근해야 되는지 여쭤보고 싶습니다.
Okay, the question is actually a freshman, undergraduate student. Yeah. So the question is, what would be the best so he's wondering what kind of mindset, what kind of direction they take to start studying in this area, like AI or computer science. Yeah, mindset also including mindset and the best way to approach.
Maybe I'm not sure if this, because this is kind of like open questions. So there definitely like multiple different ways, right, to become the computer scientist or a data scientist. But I guess because you are the first year, so which means that it's probably very important to build your knowledge foundation. So I guess it is very important, for example, to learn how computer system works, like learn some foundation units or course for AI, maybe like statistics, right? The programming language Python, so that maybe later in the second year or the third year, you will have some more advanced courses. We'll talk about different specific domains, and you also have a chance to like do hands-on project, which means that you will be trained as like a problem-solving mindset. I guess this is probably very important during your undergraduate study. So this is.
So I think the other thing is actually also a bit related to the generalist versus specialist question. So I think for fresh student, I think you need to try different areas. You need to learn different things. You need to try that because before you try, you don't know what you are interested in. Right? For example, before I started doing my master's in Australia, I also don't know that I'm interested in cybersecurity or cryptography. Right. So basically, as an undergraduate student, I think you need to try different. For example, you can take different course from different areas, right? But I'm not sure whether like the curriculum of your undergraduate coursework is very rigid or flexible. That's what I'm not sure. But yeah, I think you need to try different things.
Just one word, try different courses. Try different courses that are not their main major.
두 번째 분은 제가 잘 못 알아들어가지고 아무튼 뭐 다양한 클래스를 시도해 보라고 한다고 하는 것 같네요. 자신의 어떤 전공뿐만 아니라 그다음에 첫 번째 답변하신 분의 답변이 참 좋은 것 같아요. The question is open question. 예, 오픈 퀘스천이란 거죠. 어떻게 딱 하나로 딱 잘라서 답변할 수는 없다는 식인 것 같은데요. 근데 이제 아까도 나왔지만 두 가지 말씀하셨어요. 하나는 knowledge 파운데이션을 만들어라, 수립하라. 그래서 스태티스틱 프로그래밍 등등등등 우리가 그냥 무시할 수 있는 거 그런 것들인데 사실은 그게 굉장히 중요한 파운데이션이라는 거. 그다음에 두 번째가 이제 그 파운데이션을 한 다음에 그것만 가지고는 안 되고 그거를 우리가 프로젝트, 핸즈업 프로젝트 이런 것들을 통해서 적용하고 그 과정에서 문제 해결 능력을 키워야 된다. 이렇게 두 가지 말씀하신 것 같아요. 답변이 됐나요? Okay, that's it. Okay, no more question. One question. Yeah. Please make it short. Yeah, short, please.
I'll quickly go to the question instead of anything else. What is the impact of PQC on integer factorization problem, as it is still an open problem, or it is solvable with the help of some advanced quantum computer, or there may be some other AI technology?
Pardon, could we repeat? So which problem are you asking?
Integer factorization problem.
Yeah, okay. So basically, for the integer factorization problem, yes, so there exists a polynomial time efficient algorithm to solve this problem. However, it requires like a lot of quantum computing resources in order to run this algorithm. Which will make it impractical, at least for now, because nowadays you don't have very small scale quantum computers in the lab, right? But basically, to running this kind of Schwarz algorithm to solve the integer factorization problem, for example, to break the real cryptographic systems, then you need very, very large scale quantum computers, which we don't have at the moment. So yeah, so basically what I want to say is, we have this algorithm to break, like I say, right? But we don't have the resource to run the algorithm. That's the problem. So, and we don't know when such resource will become available in the future.
Means it's still an open problem.
Yeah, because actually, for example, I know there are some new algorithms to break this kind of problems. They are this kind of probabilistic algorithms to break also like for example ISA, right? They require probably a bit less resource compared to the Schwarz algorithm. But yeah, so basically you can see this kind of taking algorithms that are also being optimized, right?
Okay, so on behalf of Professor Huang and all the international speakers, I'd like to thank everyone for being here. So you are wonderful. You ask very challenging questions like freshmen, which course you want to choose and toward the AI and cybersecurity, and also the quantum PQC factorization NP problem. So these questions are all wonderful. So my final remarking for all of you is, for all the students here is, maybe I give you 3 words, okay? First word, focus. So focus on your interest, focus on your curiosity, and focus on your study. Second, resilience, okay? If you feel frustrated about your exam test or about your textbook things, don't be frustrated. Just keep going, okay? The last thing is perseverance. So if you study one direction, go deep. Please go deep. And this will take you far in the future, even if you change your area. But the methodology itself will apply and take you far, whatever you studied before. Okay? Thank you very much.